Right, hopefully I'm streaming. We'll see how we go. Wait for the cut. Yep, excellent. Stream starting. All good. This probably looks a bit weird, people which are joining in for the after I've streamed. It's, I don't know, seeing what's going on. It's strange. Wait for a second and see what happens. See if anyone turns up. So I've got a few things planned. I'm doing the live mailbag and a little discussion I want to have about some 3D CAD software and for 3D printing. Right. Hopefully someone turns up. I was talking to myself. Don't really want that. Okay. Hey, someone's here. Awesome. That's one person. See who else turns up. So I've got a few things planned. Since you weren't here just now, I can tell you. I'm going to do a live mailbag, and I'm going to look at some 3D CAD software stuff. So I'm looking at. Oh, I'm waiting for a 3D printer to turn up. So I should have probably announced this and pre-planned it, but I thought, oh, this morning I thought, I think I'll do a live stream. Planning's always nice though. Okay. Few people, cool. Right, I'll get started, I suppose. People can always catch up. So, first thing I want to do is just do a little shout out to some people which helped me out. I shall change views and then cover this part. Hopefully this audio comes out okay. I'm not quite sure how it's going to go, so let's go to here. And let's pull up its bloody top screen. Hold on, where is it? I want this one here first. So, a bit of background on this. This is just like a bit of an advert, I suppose, and a bit of appreciation for someone who's helped me out. I'll play this video back. So I was going to do this as a standalone video, and I decided, no, I'll just chuck it into the live stream and just do it in here. Okay, so let's play this. Right, so I just wanted to show you the new launch slide that's been put in. Well, I put it in yesterday. It's thought I'd do a little video feature on this because I really appreciate the effort the company made to get this to me quickly. They normally have a 5-week turnaround at the moment because they're so busy. They got this window, well, this whole door assembly done, double glazed, tinted as well. It did it in 10 days for us. So, you know, they pulled out the stops because they knew it was for our house, which has been flooded. So, because of that, they made an extra effort and they helped us out. So, just a little shout out to Fairview Windows and Doors in Thames, based in Kopu, in New Zealand, on the Coromandel Peninsula, that area, Firth of Thames. And I thought, well, if you want to use them for your windows and stuff, then please do, because they really helped us out. They pulled out stops for us to help us so we get this new window and door put in. There you go, it's enough of that one. It's just, I'll show you inside the house because it's coming along. It's more of a house update really, so what this is, isn't it? Let's get rid of that window there. And you can pull this one up. So this is an update on the house basically, showing what's going on with that. And then I'll start with some other stuff and go into some, you know, the mailbag and bits and pieces I'm working on. Let's get this bit out of the way. So I was going to do this as a standalone video. Yeah, there's the inside view. So I installed this yesterday. Put the spray foam around the outside for the gaps and things like that, like you normally do. But yeah, it's all good. The window's good. Painted. Let's go through a few bits. The guy started to come yesterday to give us a sample to the floor, so we can choose. Yeah. And Ethan at the bottom. Now, so we're actually in. So he's painted all this up with some nice. You might remember my video I did on the hook. So yeah, it's enough of that. So it's not that exciting, but the house is basically painted now. So that's all good. The paint's actually finished work now. So give it that. Close. So I'm not used to using this particular function of the system. I don't tend to use it normally. Let's get rid of that and pull up the next thing I want to look at, which is this. So yeah, the house is coming along. It's all doing well. So one of the things I wanted to look at is just a little bit of 3D CAD software. So I'm using Tinkercad, tinkercad.com, and I've designed this thing here. Now this is a latch, well, a lever for the HP 4261A PCBs, where the daughter cards slot in. You got those little levers to pop them out, and they break. At least they did in mine. Two of them break in mine because they're a bit old and the boards are quite stiff and that kind of thing, so they snapped. So I've actually jumped in Tinkercad here and made a new lever. Alright, so this is going to be, I'll put this on my website probably, I'll probably chuck it up there, someone may find it useful. And so I thought I'd chuck this in here, you know, and change views. It's only a little thing, it's about 28mm long or something. Hi, how's it going? And oh, get used to the bloody CAD. It's put into place this time. It's supposed to be over here. I'm not quite sure why it's moved. Anyway, yeah. So there you go, there's a views for it. Pretty basic thing. It's got like a slot down the centre of it, and so because the PCB actually goes through that slot there, and so it sits in there, and it's got like a hinge pin through there. It's upside down, so it prints in a better way. Okay, so again, and yeah, so that's the plan. So that's the part I've been designing. So the 3D printer is actually on its way. I've never done 3D printing before. Even this CAD stuff is new to me. So I did this yesterday. Didn't take me that long. Probably, I don't know, hour, maybe 2 hours. Something like. Since the first time I've used it, I thought it was pretty good, really. So yeah, I thought I'd show you that little bit there, which I'm working on. So when I get the printer and get our stuff, I'll do a video on that as well. And Onshape, no, I've only played with Tinkercad so far, and I've got Slicer. It's a slicer software I've downloaded as well. Onshape I haven't tried. I've heard of it, but I thought I'd just try this one out first. You know, just what's it? I did download. Was it Blender? But I couldn't get my head around it. It's like, oh, what the hell is this? I'm not sure this is even the right software, sort of thing. So yeah, it's being on a Mac as well. It's probably a few less options being on a Mac compared to a PC. So I'm speculating there. It may be fine. So yeah, it's just gonna play around with this and go from there. So when that 3D printer turns up, also I'll do a video on setting it up and getting, you know, the first usage video and showing how it goes, and see if I can completely screw it up or not, or if I manage to do it okay. So yeah, so obviously I'll be trying to print these little levers out to replace the broken ones on the boards, like on that unit. So I've also got let's see what I'm going to show you these handles. Now this is off the, trying to get so you can see it in shot. Okay, here we go. Alright, I've glued this back together. This is the handle off the Valhalla 2703. Ones which it turned up as all the handles were broken off. All the bits were there, so I've glued them back together. Alright, which at least means that I can measure them up and model them up in here and make new ones. I don't know if they'll be strong enough. I'll try. I'll be using ABS. I'll be using PLA. I'll be using ABS, which is a bit harder to work with, but as I have a background in plastics, I'm pretty confident. I'll use ABS normally. So anyway, here's my cup in case you can't see it. Take me to the hospital. Anyway, output low. Oh, my stream is playing up, is it? I'll have to look at my stream settings again. Hold on a second, let's jump in here. Let's drop that back a little bit. Try and help it. Oh, it's only very low, really. Let's drop it down slightly. Alright. So the next thing I want to do, also I've now discussed that 3D CAD thing, which I want to play around with. So that'd be probably more interesting when I actually get into it and get the 3D printer here and go into more detail there. So the next thing I want to look at is this. Now I want to do a live mailbag. So you think, hey, I've never done a live mailbag. Why not? what could possibly go wrong? Depends what I've been buying, I suppose. So let's have a look. I'll leave it on there, it's alright. So the audio should still be okay over here. I've got the microphone kind of central, so here's the knife. So let's see what we've got, shall we? The mower bag's quite interesting because some people seem to like them, but then I get times where I get a bunch of people to unsubscribe when I do a mower bag video. So it's like, well, some people like them, some don't. You know, that's fair enough. So look at this. This looks like the new alternative handle for the Heiko, or my fake Heiko. So I've got this one up here, right, which is, you've probably seen me do the review on this. I had to repair this handpiece, and I've repaired it a couple more times since then as well. I thought I'll try getting a different handpiece. So I saw this one online, although these probably don't have a good reputation either. So I thought I'd get this one as well and see how this one comes out. It's got this little clip together thing here, which is interesting, isn't it? Build quality is not inspiring, I have to say. That is not the best. Doesn't feel good. It doesn't even latch. Look at that. Oh man. Okay. Oh no, man, just incredible. Anyway, it came out of tip as well. So nice little knife tip. But yeah, this is great, isn't it? You know, it's like, well, oh, come on, at least make the things so they go together. That's incredible. It's probably this foam thing holding it in a little bit. Can I get it off and have a look? I can. Let's put it apart. Yeah, it's all just split down the centre. Some styrene kind of plastic, I think. It's styrene. Anyway, not the best start, is it? It doesn't actually clip together. Already don't like it. And there I was hoping I'll be getting a better alternative to one I've already got. It seems like that's not going to be the case. I might have to do some rework on that to make it fit so it'll actually latch on. I mean, what's the good of that? What's the point in that? Is it relying on the actual bloody tip, which I've now lost notice? Is it actually relying on a tip to hold the thing together? It might be. Just plug it in and see if it works, eh? It's up here somewhere. Oh, get the other one out. The plug's nice and tight. That's always a good sign, actually. Yeah, no, better turn the power on. Hold on. Does it work? It says it is. Seems to be okay. Heating quite slowly though, compared to the other ones. Maybe it's because of the tip, or who knows. Oh, we'll see. I mean, now I've got an alternative. It's up to temperature. Hey, it's working. So I can't complain too much. Now I've got 2 more tips laying around. Got to figure out what to do with the 2 of them. So I might give that a go and see how that goes. And see if it lasts or not. I've already tried this. I've actually got used to this on. I mean, this one here, I mean, it works okay. It's just the build quality is not very good, and that's what's let it down. It's just been not done very well. Okay, that's enough waffling about that one. So what else have we got here? Small ICs. something else in there. No, it's not. Okay. So 740S 107s. So when I was fixing the HP 4261A, I went through its parts list and basically bought all the ICs I could see in its parts list, because a lot of them I didn't already have, and they're fairly like jelly bean parts. I mean, 74 series parts. I mean, it's all pretty basic. I thought, well, I'll just get them anyway because they're cheap. And I bought a whole bunch. Here's some more. What are these? I can see underneath them. I feel like I need to sneeze, so if I do, sorry about that. It's going to be loud. If I could read the things, it'd be great. Wow, I cannot read that at all. We'll get the light on it just right. MC1458, I think it is. Yes, it is. It's probably op amps in. I think those are op amps. I have to think about what I do with links, because I normally do mailbag, I chuck links in the bottom, so I might have to do the same thing with this. So it's a bit of a weird live stream, this one, being in fact I've sort of gone through a few different subjects all at once. More chips. Can I see what these are? So okay, 74LS 151s. Can't remember which I was on there, but so I just bought a whole bunch of parts. I didn't necessarily need them all. Now I've actually got that 4261A working. I've fixed it, so these are just parts I'm going to have laying around now. So these are a couple of high wattage pots. These are also options for my leakage tester project, which I'll be starting that soon. The PCBs might be arriving today. This is a 2-watt pot, 100k, multi-turn. I think it's multi-turn. I can't remember. Making burgers. Oh, yeah, well, yeah. I'm not. Yes, multi-turn. So I thought that'd be nice for a little project, I'm sure, but it may or may not make it to the leakage tester. I mean, I think it's 10 turns. Feels like about 10. So, and I've got this other one here as well, which is a similar kind of thing. What's the specs on that? I'm trying to read that as well. 100k. 0.25% linearity, really. Right, and that is multi-turn as well. Feels like about 10 as well. So it's probably overkill having a 10-turn pot, but that is to go with this knob I got here before. So I've got this multi-turn knob here. So I could match that with those and use that if I needed to. If I needed that fine control. Again, I just didn't know really what I was going to end up with needing. Hold on a second. I've got a bit of a runny nose. I need to blow my nose. Sorry guys, I'll just turn the audio off for a second so you don't have to listen to it. Alright, that's better. Not struggling out now. Okay. Look at this then. Thought it was a bit of naughty doing a live video of mailbag and things like that. Different, I haven't done one before, so a lot of a mailbag. Where's packaging for that? Anyway. So I've also been buying some more tips for the Heiko. Or the fake Heiko T12 tip. It's a KU tip. So just a small knife blade. Just a smaller version one I just put on that other tip, the other handle.
So that's probably more likely to be the one I end up using rather than that larger one, actually. It feels very light. I'm not sure it's got enough thermal mass. I don't know, then this one's fairly light too. They feel similar. Right. One more thing. And to my ICs, these are Sim4LS, yeah, Sim4LS 90N, which I think we've already got some of. Yeah, I've already got 90s, not LS 90s. But yeah, again, I was just getting parts which I saw on the parts list, thinking I may get them just because I might need them. So they're cheap, you know. You're talking about, you know, a few dollars for a pack of them like that. It's not expensive at all, so I don't really mind doing that. Because eventually I'm going to need these parts for something, because the amount of things I work on. I don't know if you would have seen these yet. You probably have actually. These other projects I've got lined up. I should probably show you them actually. I'm not sure if I've done it or not. Let me just get to them. I think I might have mentioned it in another mailbag. So I've got this AC/DC differential voltmeter. I haven't even powered this up yet, so I don't know what condition this is in yet. And it's got some empty holes on the back here, and this is also, there's a plate missing, so this makes me wonder if it's got bits which have been taken out of it. I'll be finding out. I haven't even opened it, so I need to do that. But no, the lack of those rivets there makes you wonder what's been going on. Is that a transformer that's gone, or what? You know, bolts where we're supposed to be. Something's gone out of it anyway. So we'll see what the story is for that. I have to open it up soon actually. In fact, shall I do it now? What do you reckon? Yeah, let's open it up now. Let's see what's in it. Let's figure out how to get into the sun. So, bottom panel's looking quite lightly. Top panel looks also equally as easy, so let's just do the top one first, eh? Might be a little bit noisy. Come on. How's this come off? Or is that the whole thing sliding? Is it? Oh, come on. I should really read the manual on these things before I start pulling them apart, shouldn't I? It does look like a joint. It does. I know, but then that looks like one piece there, so let's take the whole piece off like that. Let's take the whole sides off. Screws down the camera right out, it's quite interesting. I thought there might be captive screws, but no, they're not. Not captive screws. Right, let's just do it. Okay, there we go. Right. There's a little guide inside there. Someone's taped it in. Interesting. Definitely interesting. I'll take the other cover off too and see what's down the bottom. So that's all the adjustments. Adjustment guide. Okay. Let's take the bottom cover off too. Board's falling out. Why's the board falling out? There's screw holes here. It makes you wonder if there's supposed to be something across here. It looks like there's a strap missing. Trying not to stick my head in front of the camera. Yeah, okay, I'm going to have to be a little bit more careful with this. Let's put the top cover back on the end and I'll do the bottom one. So I'll slop around here with. So yeah, 70 parts missing. Looks like nothing major so far, but we'll see what happens when we get to the bottom. I'll do these screws almost as quickly with the hand screwdriver, but when you get a lot of them, it's a bit of a pain, so I'll just use this. Right. What surprises the weight isn't here. Well, that looks intact. This makes you wonder what's in the back there. Now, there's a big cavity in there, but there's no like wires hanging off or anything I can see. It all looks normal. So what used to be in the back? Very interesting. So that's all fine, it's all secured in nicely. That all looks alright. Kelvin Varley voltage divider apparently. Cool. And it's using precision resistors. Can't really see that probably, but probably just see them in there. Get the angle right. So back to this side. So again, all looks to be intact. I can't see anything that looks like it's been taken out or anything missing. Obviously, you know, there's got those witness marks there, but that's a bit odd. And also, I need to make some kind of rail to hold these boards in so they don't rattle around. But it looks intact. Capacitor there looks okay. There's a sign of leakage. Can't see anything burnt. It's all looking good. There's a transformer in the back there. It looks okay. I could try powering it up, eh? Could do that. See what happens. See if we get any smoke. Time to finish my coffee off, which is now a bit cold. Right. Power it up. No bang so far, that's always a good start. How to turn this thing on? Here. Was needle movement. It's interesting, it's got like a, was it 1, 2, 3, 4, 5 position power switch, which I find interesting. I can see a wire moving around down here, rubbing against the shaft. I'm sure that's not a good thing. So it's got some activity there. So it's off and is off, and they're both two different things. I need to look into that. Oh well, hasn't gone bang. And it's got some kind of activity there. So I have to play around with this and figure out how the thing actually works, because I've got no idea how it works yet. Cool. So anyway, didn't go bang, and it still seems to be there, so it's always a great start. So this will be a project later on, I expect. I'll probably have to refurbish it, you know, replace some of his caps, that kind of thing. What kind of print am I getting? That's it's from Banggood. It's on special. I will, it's a Prusa i3 or something, I think it was called. Let me find it. I'll pull it up and I'll show you. Again, I don't know much about 3D printers. Well, this is really struggling in my stream, isn't it? Let's drop it down a bit more. Well, obviously my internet connection is a bit inferior today. Okay, let's pull this thing up and I'll show you it. I'll basically take a guess. It's on special, and I thought, well, you know, I don't really know what I'm doing when it comes to 3D printing, so I just thought, well, I'm not going to get the cheapest one. I'm going to get something slightly better than the cheapest. I always tend to do that. I don't even get the cheapest thing. Right, let's show this up top screen here. Between the window and do this. Right, there we go. So you should be able to see that once I change screens. Alright, so this is what I've got. Let's zoom the thing in so you can see it a little bit easier. There you go. So I mean, it looks okay. It's got a metal frame. I don't like those plastic frame things. So it's got aluminium frame at least. So it should be a bit sturdier. It's got V slots and stuff like that for accuracy of the movements and guides. Ender, I don't know about that brand. Never heard of them. So it's a Prusa i3, I think it's i3. It's a 220 by 220 bed. Oh, hi Ian, how's it going? Good to see you getting better after that illness you had recently, Ian. That's, no, it sounds like you had a bit of a close call there. So yeah, it looks okay. It's got 250 height. In theory, I'm not sure it goes right up to there somehow. It's 220 by 250 it's supposed to be anyway. So we'll see how we go. I mean, it's going to be interesting. I mean, I've been wanting to get a 3D printer for a while. I've been putting it off, and thought, well, do I really want one? They've had a few things recently where, a few things recently where the items are broken like that on that HP 4261A, where those little levers are broken, which is what that's for. And also on the Valhalla, those handles are broken, so I want to make new handles for that. So there's been lots of times where I wished I had a printer, even on my Fluke 343A DC calibrator. That had all the little standoffs are broken. A lot of those they're polycarbonate standoffs, and they're all broken on the front panel for that. So printing is a lot of time. Yeah, I know it takes a while. I know it takes a so long process. Designing it is the quick bit. Yeah, it's a handy little tool to have, I think, and that's why I've decided in the end just to get one. On the Fluke 343A, when I found those little standoffs were broken, I did sort of try and build them up with hot glue and things like that, and epoxy. Depending on how well I could access it, I used epoxy where I could to try and build up around them so they wouldn't fall apart. I mostly glued the bits back together and epoxy around them so they wouldn't fall apart completely. So it wasn't great, but it's not going to fall apart. I really, in that situation, would like to make new parts. And now, if I get this printer, you know, when it arrives and I can use it, hope I can use it, then it'll be good. Quite addictive when you get started. Yeah, I'm sure it will be actually. Yeah, if you keep finding little things to make out of it and tinkering around with it. Laser cutter, yeah, that's pretty cool actually. I mean, you can always find uses for things. Eh? If you got the gear, you can always find a use for it. It's always pretty good. Like this printer here is supposed to be able to do resuming, so you can stop it halfway through a print and have it resume. However, my plastics knowledge says then you're going to get a weak spot in that area because you've got cold plastic fusing with hot plastic. So you're going to get a differential because of the shrinkage. So the hot will shrink as it cools, which means it's going to tend to stretch, and it'll be a weak spot there. And you want maybe not adhere as well to the second part or the original first layer. So it's best to go hot onto hot, or at least hot onto warm. At least going hot onto cold is potentially bad, but I can understand why I've done it. It may not be critical in some situations anyway. Raspberry Pi is something I've actually played around with, and I've seen it mentioned heaps, and lots of other people have mentioned it and used them, and it's not something I play with. I probably should, but as I'm not really a PC person, it makes it a bit trickier for me, or Linux or whatever the hell things are on. So yeah, it's a bit of a. It'd be completely foreign to me. I probably should look into it. I mean, it's so common these days. I probably should when they're cheap. Yeah. I mean, making spare parts would be the ideal thing. That's what I want. That's what we all got it for, because I'm always fixing these bits of gear, and I'm always finding broken things. And it'd be so handy, Or even I might see something which could be improved, and I'll just make a new version. That could also happen too. And making things come by, certainly like those handles for the Valhalla. I mean, they're smashed to pieces. I'm sure I'll glue them together, but I wouldn't trust how I wouldn't pick it up with them. And you wouldn't be able to get new ones. And then the old ones you could buy would be the same kind of condition. They'd be quite brittle and fragile. Plastics go brittle after a while. The UV breaks down the molecular bonds, and they get a bit weak. So it's certainly good for that. So yeah, so this is on its way. It should be here soon. It might be here this week. And it's got a hotbed as well, 110-degree hotbed, which you need for doing ABS. And I tend to do ABS. I bought a whole bunch of ABS filament. Because if I'm making something, I want it to be strong. I don't necessarily want it just for decoration or for, anything I'd be. Anything I'd be making would be structural. So ABS would be used for that because it's tougher and a bit stronger than PLA. It's just harder to work with. So aluminium frame. Manual leveling. I thought, well, it's my first one. Manual leveling would be fine. It's a little bit fiddling around, but. Yeah, I'm not really too worried by that. Sure it'd be auto leveling be convenient, but yeah, you can see other stuff. Example, rubbish, yeah, blah 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 blah. Yeah, a whole bunch of irrelevant stuff. So, and there's other ones there. So, obviously you can spend silly money on printers. You can spend thousands easily. So that's not what I want to do. I just want something small which I can do little minor repair parts with and make little bits and pieces. So that's the plan with that. And so yeah, I've already done the first model. I've got Slicer. Let's open Slicer up and I'll open that model up and you can see how Slicer displays it. I've been looking around trying to research what softwares to use, and I'll just pull this up and get it open and I'll drag it into the window. So there's a Slicer view there. And there's the layer preview. So I'm trying to do solids. I'm getting some weird artifacts like this, which is interesting. I wonder if it's, I don't know, it's doing some little glitchy stuff. Slicer seems to be. I've done a few little glitches on it, whereas I did something else and I came back into it, and it just disappeared. It wasn't there. But it was there. But it wasn't. You couldn't see it. So I thought, oh, that's strange. It's gone. So I dragged another way, and suddenly I had two. I had two parts side by side. So I thought, oh, at least I figured out how to, do duplications of, just lay up two models at once. I figured out how to do that by accident because the first one vanished off the screen, which is a bit weird. I don't know why I did it, but it's been a little bit glitchy. So that aspect has already made me a bit nervous about it. There's a Prusa edition, is there? Okay. have a look. So this is just slicer, because I don't really know what I'm looking for with that. Let's just pull this up and find a window. So there's a Proof edition. Right. Right. Okay. I shall bookmark that and I'll look at that later on. Thanks for that. Bookmark. Where the hell is it? Bookmark. Yeah, bookmark. Stick on the top of the thing. Hold on, let's just set this up. There we go. No, that's not where I want to put it. Hold on. I messed it up. No, it was in the right place. Why didn't it show up? No, hold on a minute. Here we go. Right, it's fine. It's fine. Just me confusing the hell out of myself. I need to rearrange that before I lose it. Hold on a second, this is me being a bit slow. Where the hell has it gone? I've got too much stuff on here, I really need to clean this up. It's way too much stuff. Come on, scroll. Right, here we go. There I want. Put it where I won't forget it. Okay. And my stream is dropping down again. Yeah, my stream's struggling. Wish my internet connection's better. Has some tweaks, does it? What do you know about it? Because I don't know much about the 3D printing software and stuff like that. I'm a real newbie at it. So this is, you know, this model was as far as I've got with it. You know, obviously, you know, I've done that. I have a little bit of a insight, I suppose, to the modelling side, where my job involves some involvement with this. To a limited degree. I don't do modelling, but I view them and analyse them. I can't go too much detail about that, but that's what I kind of do. Not completely, it's just from time to time. So I've got a little bit of understanding how things are put together, but which is probably why I didn't take too long to do this. But so I'll definitely grab that other version later on and have a good look at that and compare it. If it's more suited to the printer I'm getting, then that'd be good. What else can we talk about? So I've got that thing there pulled apart on a bench. I could probably put it back together actually. Shove it back together again. Desk. Here we go. Right. So hasn't gone bang, so I'll put it back together. So the fact it hasn't gone bang is always a good sign, isn't it? Just wondering about how these clips are holding up. They seem okay. I have to look at the manual and find out what that what used to be in the back there, because obviously something has been taken out of the back. And I've got what I've got there. I think I've already showed that, haven't I? The what the hell is it called? Thermal transfer standard. That's right, Fluke thermal transfer standard. That's the other thing I've got there, which I've powered it up. I haven't tried using it all yet. So I've got a few little projects on the go there, and today, hopefully, some PCBs will be arriving from JLC PCB, who are sponsoring some of my videos. Well, kind of. I'm debating that association, to be honest. I feel like I'm selling out a little bit. You know, I just don't like that whole commercialism in that way. It's what they're asking for is probably more than I want to give. I'm getting there. Where's it going in? I think that clip might have shifted slightly. Why is it not going to go in there? Where's the clip gone? It's shifted. Oh God, I'll take my work off again. Right. So I've also been approached by PCB Way, who I've actually used before in the past, and they're also interested in sponsoring my channel too. So, but they've been a lot more open to what they want. That cliff's falling off. It's very loose on there. So what's your guys' opinion on the sponsorship of the channel? Having some, you know, having to put a little bit of advertising in the video in order for me to get some sponsorship. What's your opinions on that? Does it bother you much? I want honest opinions. If you don't like it, say so. That's fine. I don't want to do anything which is going to be what's the word I'm looking for? No, it's bad for the channel. Anything that's bad for the channel. You know, I don't want anything which is going to be, you know, affect it in a negative way. That's really not sitting right. So it'd be interesting to hear what your opinions are on those. I mean, I don't mind doing stuff which is relevant, like PCB manufacture. That's relevant to most people. Watch a channel. Well, certainly a high percentage, I'd say. And then equally, you're probably used to doing it yourself anyway and don't really need it. I'm going to stick some adhesive on this just to hold it in the right place. So, you know, it'd be interesting to hear what you guys actually have to say about it. Because, you know, I don't want to be doing stuff which makes the channel seem like an advertising channel. It's not what I want. You know, it's supposed to be, you know, the way it always has been, just me fiddling around with things and fixing things and trying to keep things a little bit interesting. But equally, I want to also make a little bit of money from it to help pay to keep it going. You know, I'm not trying to make millions or anything like that. I just want to have enough money to buy bits of things like this. You know, that's what I'm trying to do. Buy bits of interesting gear. So it's going to work now, hopefully. Try and glue it in place, and it should be right then. Good luck. Yeah, there you go. It goes in there. Any opinions? Anyone want to share their opinions on that? And do you mind me having the sponsorship stuff? You know, having a 30-second advert in the video from time to time? Does that bother you? I do want to hear opinions, because I mean, I can imagine that. Sure, you'd rather not have it at all. You just want to see the content, but you know, is that too much of an imposition to have a little advert, you know, 30-second advert or 10-second advert in a video for someone which is giving me money or giving me services? Yeah, I mean, JLC PCB have been around a lot. I've seen them feature on a lot of other channels, but what I'm probably disclosing a bit too much for this, but they basically, I did a little 10-second one on a couple of my videos recently, and sent it to them. So look, you know, this is what I've done, and they wanted more. They wanted the 30-second, and they want links to the sites, and you know, you can understand that from an advertiser perspective. They're contributing. They want more, you know, to get as much as they can out of the money they're providing, but they're not giving me that much money. And I thought, well, it sounds like it's getting a bit much. I didn't really want to do too much in the channel. It, you know, detracts from the channel. It's not what I want. And then, as I was sort of having these second thoughts about JLC PCB, I thought, well, okay, well, I might just not do that then. Just not take that sponsorship and just do this little bit for now and do this deal with them for now and then end it after that. Because I'm not comfortable with it. Then PCB Way got hold of me and said, hey, look, you know, I'm interested in sponsoring your videos. Oh, okay. Well, I'm guessing that's because of the JLC PCB flagging. I'm guessing they found it that way. And they've also offered a sponsorship, only on much nicer terms. They basically said the video, you know, I said to them, I want, you know, the video's my own. I want full creative control. I don't want to be influenced in that way. I just do what I feel is right. And they said, yep, that's fine. And that sounds like a much better deal to me. So I'm likely to be switching from JLC PCB to PCBWay. I've used PCBWay and I've used JLC PCB now as well. For this project, I had to make a bit of a module. So this is for my leakage tester, which I think I showed the PCBs on that before. And let's change cameras again. Hold on. Get back over here. Let's just change camera views and I'll get back to my train of thought if I can. There we go. Right. And get back onto the stream so I can see what you guys are saying. Yeah, okay. Helmet, yeah, helmet. Yeah, I agree completely, helmet. That's right. So if it's relevant, then people won't mind so much. If it's interesting, it's an interesting thing to them, then it's probably more tolerant. But if it's not relevant, then yeah, I can certainly see it being annoying. And yeah, JLC PCB is popping everywhere because they're heavily pursuing sponsorships and agreements with creators like myself. So I've sent one PCB design to them, which is for my leakage tester project, which should be turning up today. It got here really quickly. I only did it. They started processing it on Wednesday last week, and it's now Tuesday. It should be arriving today, I think. So that's pretty damn quick, I have to say. But is that because of a advertising outlet instead of making sure it's really quick, or is it the normal process? Is that quick normally? I don't know. I don't know. So I suppose anyone that's used them normally would be able to answer that question. But so that's for my leakage test project, and that'll be coming. And then I have to sit down and look at. I'll probably do a video on assembling that thing and putting it back together, and trying to see what actually works. I've got ideas. I've got concepts. The project the PCB I've done, I've got various options built into it. So if something doesn't work, I can just use a different option. So it's one board which has got these different features in it. So I don't have to use all the features. I've got an op amp in there to amplify the signal or the voltage level from the current shunt. So if I can't read the values well enough, I can use the op amp to amplify that. I've also got a tap off point for a analog ammeter, things like that. So I've got little details like that going on there. So so that's the current arrangement I've got with JLC PCB, is that board, and I've got to go through like a spiel about JLC PCB and things like that for that. So it's quite a costly thing. The board itself was cheap. Well, it would have been cheaper. My board was slightly too big. It was above the 100mm dimension, so I end up going to the next level, so it cost more. But then I did DHL shipping and stuff like that, which cost even more. To get it here quickly, I thought, well, I'm not paying for it, so why not? They want it. They want their advertising. They want it quickly, so they can do that. If they don't want to do that cover postage, then that's fine. They could have changed the postage type. That would have been fine. It would have taken longer to get. So yeah, so that project would be interesting. It could be a complete disaster. I haven't done any prototyping apart from some basic playing around with voltage multipliers. That's about it. Trying to read what he's saying. Yeah, I mean, at the moment they're advertising like 10 prototype boards for $2, right? And for that sort of money, obviously you've got to pay postage, and that's going to add on to that cost. But that's a good price. You have to admit, if you're prototyping stuff, you just want a short number of boards just to try concepts out. You can't go too wrong, can you? But a lot of other companies will do the same kind of thing too. If you want more high numbers, and I think that's where things level out a bit, but I haven't actually looked into it. But I've used PCBWay in the past. I've also used Eddie Crow, is another one. and they've both been really good. I think Elecro quality of the silk screening was slightly better. There wasn't much in it. So we'll see what this GLC PCB one comes out like. I mean, I'm sure they're going to do a good job on it because it's going to be videoed and stuff and featured. So I'm pretty sure they're going to be doing their best to make sure it's good. So it should be interesting. So I've got a few projects that are lined up. You know, obviously I've still got back to the Fluke 5200A, that calibrator there, which is sitting just down here, up against the wall, trying to take up as little space as possible, which is not easy for that thing. So I've got to finish that repair off. I was waiting for some more parts, which have now arrived, and I've kind of had a bit of a break from it. I'm tempted to go back to it, but also the calibration procedure requires that piece of test gear just there, which I just showed you, and the transfer standard, thermal transfer standard. Those are two bits of gear which are specified in the calibration procedure for that unit. So I want to use the gear which is specified and see if that gives any different results. Let's pop the chat out of this and just try and get this Windows down a little bit. It's a bit busy right now. That's better. So yeah, so I've got a bunch of projects. House is coming along, waiting for flooring people for the house. They're supposed to be on Friday, didn't turn up. Didn't turn up yesterday, haven't turned up today yet. Not looking good. Billy Crow, okay. Well, at least they back up, you know, they back up their product at least, and they'll re-provide new ones. That's a good thing to know. That if you're not happy with it, they'll do it again. That's actually quite good. I haven't actually had any issues where I've had boards which I haven't been happy with yet, but I don't do a huge number of boards. I only do things from time to time. Yeah. I mean, I used to make my own PCBs. So I'm fine. Hold on. I used to make my own boards as well. I think we all have at some, various times. See if I can find one. They're buried in this drawer here. Examples of boards. Underneath all these batteries. You always need batteries, so there we go. There's different versions, are they? Yes, there's different boards. And this one here as well. Yeah, there you go. So here's a few boards which I have made myself. These are CB radio conversion boards. Don't do these very often, these particular ones. So this is just an EEPROM board, right? Onboard voltage regulator. Come on, focus on that. Focus on that. Go on, focus on this. I hate this camera for focusing, it's bad. There we go, kind of trying. So, this little EEPROM board, that's not a basic thing, handmade, did it myself. Just with a transparency film and ferric chloride and that sort of stuff. And these are similar versions. This is a different type. It's got a PRO on board as well. Similar kind of thing. And here's another one, which I think is a different variant, is it? Yes, and this is a newer version of this one. Alright, so this one's more surface mount stuff on it. Not a lot more. But it's when I was playing around with circuits. This one's my professionally made one. Try and get the thing to focus on it. So there's my original, here's a professionally made one. So you can see the size. Obviously I haven't optimised it. Get the thing to focus would be great. Come on, focus. Oh, this is awful. Alright, so there you go, gives you an idea. Trying to get level. I mean, basically I just copied the design as laid out on that PCB. I think that was probably the first one I did, actually. This might have been the first one I did on a proper PCB manufacturer design. So it's got some surface mount in the back there as well. A little bit of that. But, so obviously I could have optimised this. I mean, it's using EEPROM for a start. But I already had the code written. I had the circuit works. I know this works, so I didn't want to sort of reinvent the wheel. I don't use many of them, so I don't mind using EPROMs. I've got stacks of EPROMs. I've got tubes of them, because I thought I was going to be doing a lot more of these than I have, because I haven't really pursued it. I think I've probably done about, I don't know, 20 or 30 of them, something like that. And I think I've got probably 50 EPROMs in tubes, if not more. So, yeah, it's one of these things you do them time to time. I get carried away. If I know I can get something right now, I'll buy a bunch of them, because in 6 months' time you might not be able to get them, or a year's time, or 2 years' time, or whatever. When you need to restock, you might find you can't get them anymore. So I always buy loads. So as you can probably see in my mailbags, I buy a lot of stuff when I think I can get it. Yeah, I mean, time is one thing. If you need it urgently, then do it yourself. You can't do that, because you can have it the same day. You know, you can have it a few hours later. It's done. But if it's a longer term project and you can wait a week or two, then, and you want to make it easily repeatable, then why not just get it professionally made? I mean, say the costs aren't that high anymore, not like they used to be. For drilling the holes, I just use a little Dremel. I actually got a, where the hell is that thing? I don't know. Things are everywhere right now. I don't even know where it is. It's making me think now. I've got a little Dremel, battery powered Dremel. There's a little bit of a story behind that too, actually, how I got that. But and I've got a drill press, little Dremel drill press thing. But I've always just done it by hand. I found just doing it by hand with Dremel, just lining it up and drilling it, it's fine. You know, it's really quick. Bzz, 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 bzz. It's nice, easy. The drill press, I've tried it. I found it slower. Although you can get it, you know, I found the accuracy wasn't quite as good either. What EPROMs have I got? I've got 2716s, 2732s. I think that's what I've got, is those two styles. Yeah, because that's what I was looking at using, is those two. So I've got a whole bunch of those. Again, I bought what I thought I would need, and I've probably got a lifetime supply of EPROMs. I don't see me using them all really. It came with my CB radio work. You know, I was doing repairs at the time, and of that style of modification was quite common in those days. So around that time I was designing that board and that stuff, it is EPROM based, and now Arduino's around and so on, and PIC, you can do it in other ways. I've done EPROM conversions now with Arduino instead, so it's reading binary on the Arduino and outputting binary, easy. You know, just acts as an EPROM, and it's far easier to program. If you're doing custom code, you just go in there and just read the binary in a decimal format, do a conversion, adding, subtracting, and spit it back out the other side. It's easy, and then we're driving LCD display and that sort of stuff as well, which is something I've done. And it's just far easier than doing EPROM, sitting there working out the hex code for each individual channel when there could be 200 of them. You'll sit there, work out the hex, and then you'll work out if there's a 10 kilohertz offset and stuff like that, so you have to do another set of 200. Things like that. So yeah, anyway, that's another story, I suppose. That little Dremel, I'll give it a story there. It's not particularly exciting. Well, not that exciting really, probably, but I used to run a hotline server many years ago. Some file sharing hotline server system was what was around. I think it's probably long dead now. And I met a guy in there who wrote software as I was tinkering with software, and we got friendly, and I wanted a Dremel, and it turned out the one I wanted you couldn't get in my country, and this guy was in the USA, and he could get them over there, and he actually bought me his Dremel, sent it over to me, and it was pretty cool. And this is 15 years ago, thereabouts. Must be about 15 years ago. And so yeah, the only thing is it's a 110 volt charger, so I have to use a adapter to 240 volt to 110 volt adapter to drop it down. It's just a transformer basically in the box, and so it works. It's got lithium-ion batteries and stuff like that, and it's still going strong. 2 batteries came with it, and it's still like new. It's awesome. Runs really well. I really don't regret sorting it out. It cost me a bit. It's a bit of effort, but it's well worth it. 3-leg supply type. Fuse link proms. I'm not familiar with those. Oh, my stuff's been dual supply, single supply, sorry, 5 volt regulated. I'm not familiar with that older stuff there. That's a bit before my time, I think. Yeah. I've been lucky. I don't think I've broken any drill bits yet. I don't think I have. Might have broken one. Not sure, but I'm careful. I tend to brace my hand on the bench, so I've got my hand resting on the bench like that. I'm just pushing with these fingers just straight down like that. So basically, my hand's acting like a drill press. So it's I can get it quite straight. If you go over sideways, then yeah, you can snap with a drill bit. So I think I've been alright with that. WQS 1001 Colonial FR360. Doesn't ring a bell. Pre-1978, yeah, that's... Yeah. I started messing with EPROMs in... I would have been 16? 15, 16, first time I did an EPROM. Around that time, so... so many years ago. So 90s, late 80s, early 90s, around that region. I was playing on new prompts. So actually, there's an interesting story about that. A mate of mine was doing a CV modification. He'd been designing it for a while with an EPROM, and he'd been working on it for weeks, or months off and on, just tweaking it. And I was around his place. He's telling me all about it and showing me what he was doing. He's planning to go and program the EPROM the next day at the local university because he's working there, and he's going to use their lab and program the EPROM on their computer there. I thought, oh, that sounds pretty cool. And he gave me a quick crash course on the hex, how to work out the hex, and how the EPROM works and that sort of stuff, and the binary inputs and outputs, and at that point I knew very little about it, almost nothing. Hex was new to me. And that was about, I don't know, 8 o'clock in the evening, something like that. And I thought, oh, this is really cool. This is, brilliant. So I went home. I actually wrote the code for an EPROM that night. And went back with him in the morning, and he went up to his work, and we did these EPROMs. And mine worked perfectly. His had issues. Like, wow. He couldn't believe it. He didn't believe that I'd done that program overnight. It's for a Cobra 148 GTL. GTL DX is for the UK-ish version, it's like European version of 148, which has got FM on it and stuff like that. It is the PB879, is it? Chassis, something like that. It's got like 3-band on the front panel, and so I converted it. I think I gave it 6 bands in the end, something like 10k shift, things like that, and UK channels. I did all that. I designed that in about 4 or 5 hours. So that's pretty cool. My mate couldn't believe I did it overnight. He was astonished. And if I try and do something like that now, there's no bloody chance. I'm not as sharp as I used to be. Anyway, so I'm waffling a little bit now. 1984 Z80 systems. Oh yeah. Yeah, plenty of EPROMs back then. Yeah, definitely. 2 holes a second once you get up to speed. Yeah, I suppose you could do. 5 microsecond access time. I don't remember what the access times and stuff were for EPROMs. I mean, that isn't a spec that never actually mattered to me because I wasn't doing digital systems, so I was just doing a binary input from a channel selector switch, and then that gets converted to another binary output to go to a POL. And so that time delay, the channel switch is the slowest thing in the whole system, so the delay of the propagation of the EEPROM and stuff like that just didn't matter. It was insignificant. It really just didn't matter. So I didn't even consider those at all. So let's look at this. So looking at for this radio stuff, what was it gone? WKS 1001. So those radio chassis you mentioned, Daniel, assuming you're still there. Do you know the PCB number? If you know the circuit board number, I can cross-reference a bit easier, because there's so many models of radio out there which use the same circuit board, and if possible, knowing the circuit board number means I can give you information on a different radio, but it's the same board. AD80 programs, no assembler, just manual source code hex. Yeah, hex is great once you get your head around it, and you start to be able to do the conversions in your head. And that's what I found when I was doing a lot of it. I went for a period there and I was just writing a whole bunch of EEPROMs. I just did one after another for different CB radios and different functions. So I think I spent about 3 weeks probably just rewriting and making EEPROMs for things, because I just went through a little phase. I just wanted to do a whole bunch of them. And by the end of that, I think I had, I could do it quite quickly in my head as well. Didn't have to do conversions, or it's just a bit easier. I had a conversion chart, but then I made a little chart to make it easier to just quick glance over and convert it. And but at the end of it, I was doing it in my head. But now I don't really deal with hex much anymore. Yes, I'm doing EEPROMs, or maybe some coding on the computer, maybe. Yeah, well, when you get used to doing stuff, you just do it over and over again, and you just, if you keep it up, you can do quite amazing stuff. So let's see. You still there, Daniel? Where have you gone? Because if you can tell me that circuit board number, I can have a look and see if I've got so much cross references. On my Radio Mod site, I think just about all my information is on the Radio Mod site anyway, but there is a bunch of stuff which isn't there, which I just haven't got around to putting up there. I haven't really updated the Radio Mod site in quite some time. I think the public section I haven't touched for, I don't know, 10 years maybe. Right, so yeah, it's certainly better to type in hex than it is to type in 10010001. Hex is far easier. So yeah, I'm saying, so I do have a bunch of information. I'll drag this window up and I'll show you here. Alright, so here's a bunch of information I've got sitting here in a folder. It's all good. So let's just do this again. Hold on a second, let's try and hold on, let's try and change my toolbar thing around. Hold on, this is not looking right. Where is that? Can't find it. Interesting. Let's hide those. Here we go. Right, so it tricks back up here. So I've got a whole bunch of information here which isn't on the website yet, which I just haven't got around to doing, basically. Some of the stuff's already out there. Things people have sent me. I've got some diagram stuff in here, various things. The members here I've updated a bit more often, but not as much. I've just got busy with other things. The Radio Mod site, it became a great thing. I mean, for a while it was like the #1 CB radio website on the internet. It was #1, and then CB Tricks came along, and they've done a great job as well. And they became, I believe, #1, right? But that seems to, my understanding is that CB-Trix is not being updated anymore either. I think it seems to have just stopped, from what I've been hearing, which is a shame. So there's concern about CB-Trix dropping off. I mean, on my site, I'm going to keep my site going forever. Right? I don't ever intend to turn it off. It'll just sit there. But maybe one day I'll go back and start putting things like this in there. I've got various bits and pieces in here. You know, Kenwood stuff. Oh, this is just a bit of it. So you're looking for Stag. Same Stag 357. Let's have a little look and see if I can find something. Very little to nothing. Yeah. Okay. Hi Steve, how's it going? Let's just have a little search, see if I can find something. Name doesn't sound familiar again either. Stag 357. See if I can find anything on that. So a quick look through my files. It's not looking hopeful there. So yeah, so what you said, you want WKS 1001. If I type the right numbers, it'd be helpful. I've got something here. Let's have a look. What is this? Waiting for Photoshop to open because I think it's a Photoshop file. It's probably a circuit diagram. We'll find out in a second. Once it finally opens, yeah, circuit diagram. So it's a circuit diagram for the WKS 1001. MC1 for 5106 POL. Okay. Does it tell me the circuit board number on here? I don't see a circuit board number, which is a shame. That looks like a Uniden chassis. I mean, it's got UPC 1156H. That looks like a Uniden chassis. 1156H is used in like the PC879 in Brightly. This diagram might be in my public area on my website. I'm not sure. It may or may not be there. I don't know if you've had a look there yet. Yeah, I'm not seeing a. I'm looking for a board number. I can't see a board number anywhere. Yeah, this is. Oh, you know, this is a Uniden chassis. This is Uniden design. But yeah, I don't see a board number, which is a shame because if I could find that, it'd be a bit more helpful. Could probably cross match. But so this is a circuit diagram. So what kind of alignment information do you actually need? Yeah, well, so it looks like a Uniden board. That design looks like Uniden to me. Just from the circuit diagram, the layout, and the componentry. You know, NC1 for 5106, Uniden use those. You know, Uniden make the boards of Cobra and behaviour. Let's just have a look at this stuff here. I need to get my head into radio mode now. So it's got individual crystals here for each mode. 11.415, 11.412, and 4158. Those are interesting frequencies. I have to say I haven't come across those frequencies before. So I go through here, should be buffer / triple R mixed in with the VCO. Yeah, interesting design. I haven't actually looked at this design before exactly, not this particular one. it's got a mixer here as well, which will be generating the final output. So what the VCO frequency runs at then? That's interesting. Could calculate it, I suppose. Similar to an Adams, you reckon? Adams uses a UPD POL, remember rightly. Is it 858, UPD 858, I think it uses? Let's have a look, shall we? I will have that. I also have something else here. Let me just have a look at this and let's see what comes up. Hold on a second. Not sure. Oh, yeah, on that. Just trying to find the right bloody thing for it. Just trying to have a little look. Okay, no, it's not it. It's just confusing me. Why did it come up in the search? Okay, no, that's right. It's a page which lists the POLs and different radios, and the WQS 1001 come up as a into 145.106 POL in that list. So that's, you already know that anyway for the circuit diagram. So that WKS is all I've got is that diagram, it would seem. So what's the other chassis? It said Kernel FR360. Let's look for that too, shall we? I haven't done much radio work in a while. I mean, I've been asked to do some radios this year. I had to turn down a few guys. I've got nothing on that chassis radio, on that FR360 radio. It would seem. Not much. Again, it's just listed as a POL type. Let's try and find that. Did find something different. Just trying to locate it. Oh, maybe didn't find it. Really? Interesting. I found it in the file, but then I can't find it in the file. That's weird. That's weird. Okay, maybe not then. I forgot what I was saying. So I haven't done much radio work, and I've had to turn and get people down for radio work because my bench and stuff isn't set up for it at the moment. And I don't do a huge amount anyway. I mean, you know, I might do. I don't know. It varies a lot. It could be like a year goes by. I don't touch a radio. So the radio you want it for is the Kernel FR360. Is that right? Is that the one you actually need? Because the WKS is different. So I'm just checking my email to see what's going on here, because the eBay listings have come out, so I just need to see if there's anything on there which I'm looking for before they get snapped up by somebody else. Hey, if anyone wants to have a go, there's a Fluke 5200A AC voltage calibrator, something I've been working on. The starting bid's $24. Yeah, I don't know. I don't think anybody wants the same hell that I've been through trying to get mine working. Well, that's identical to President Adams. Well, let's put a President Adams diagram up, shall we? Let's just find that. Hold on. We'll do a comparison. Adams. President Adams. Why don't I see it? I must have that. I don't have President Adams on my list. That's weird. How the hell does that work? That is strange. Oh well, still search. Oh, here we go. I do have it. It's in pieces. Come back. Right, I do have Adams circuit diagrams. This is a little bit different, I think. Yeah, that's not good. this is an old Sam's, and this is no good. That's corrupted that file. That's what I thought. Let's look at the PL section. Let's see this. Yeah, and this is a bloody Sam's manual, and it's not a very good copy of the Sam's manual either. Look at the state of that. So this is what I've got for the Adams, so I can't really compare it because it's not the original manual. Can't really do a great comparison there, not easily. I have to analyse it. Got another one here. Let's look at this one. If I could get my bloody computer to behave, it'd be great. Oh, that's only a little fraction of it. Oh no, these diagrams are from 2001, and yeah, these are Sam's ones, and they're not very good. The quality is really poor, so I can't help much with that, I'm afraid. It's not looking good for you. I'm assuming you've already looked on CB Tricks, because I mean, if I've got it, they likely have as well. If it's not covering full frequency range, then the VCOs can age as well. It depends on the VCO system. If it's got like a VCO block, like some of the cybernets do, then they can fail. But I don't believe it will have that. It probably is the stage capacitors. I mean, there'll be a tantalum cap in there somewhere, which will be for the phase detector filtering, and likely that's on its way out, or electrolytic capacitors in areas on the way out. Power supply problem. It could just be purely alignment. It could just be that some values have gone off slightly and it's just out of alignment. I can tune a radio without a manual. I can do it. It's as long as you know the concept of what's required. In most cases, you can't do everything without a manual, but you can do frequency alignments mostly without manuals. VCO alignments certainly. If you can find the phase detector test point which checks the voltage out of the POL, then you should be able to do that, and you can tune it based on the voltage coming out, and then check each end of the band in TX and OX in case the switch for TX and OX. Well, there's nothing on the diagrams about the PCB number, so, but then that's not always the case. You know, I've seen lots of diagrams with no PCB number, but there is a PCB number on the board. So, yeah, I mean, just give it a go. Just do voltage measurements on the phase detector output from the POL, and just try and tune the VCO that way. See if you can get it to capture on TX and RX. So some radios like the Cobra 29s, the frequency changes between transmit and receive, and so you have to make sure you measure that VCO voltage on both states, and make sure it captures. It's within voltage range. You need at least like 1 volt at the bottom end, and about 4.6, 4.7 at the top end, something like that. Mid, high and 10 meter band. Okay. I'm not friendly with that radio at all. But most things you can figure out usually by poking around and just seeing what works, what doesn't. You know, a manual is always nice to have. You can try and do an alignment to the manual, but it's always great. But if you can't get a manual, then just play it by ear and see what you get. I mean, usually you'll find you can get a good result anyway. You know, you don't have to be super precise. The only thing you've got to be precise about is frequency alignments. Everything else, you know, just make it work. You know, if you don't get the receiver alignment bang on, it'll be good enough to work. Transmit good enough to work. You know, it'll be fine. You know, you might have to tweak around, go back to forwards between alignments and get stuff right. But you know, I'm waffling about CB stuff. Like, I haven't done any CB stuff myself for a little while, have I? I mean, I did some odd stuff. I've done some conversions and repairs. I've got a stack of radios I need to work on. The ones that got damaged in the flood. I need to get all those out and see what condition they're in. Because they've all got flood water through them and salt water. So I need to, once I get back into my house and the lab is all back together again with the radio gear set up, I can do radio work again. Then I'll start digging those out and go through them, and I'll do some videos on those, trying to see if I can recover any of them or if they're all ruined. I flushed them out with clean water, and we'll hope for the best. Clean water's got to be better than salt water. So, but I haven't looked at them in a box, waiting for them to get to them. So I don't know what condition they're going to be in by the time I get them back out. They could be. I mean, that's 4 months ago now, that flood. So they could be completely stuffed. I'm hoping not, because I had some of these radios winches I've actually worked on, and I was trying to sell them, or ones I got into repair and fix up to do videos on. So it might just be that I'm doing different videos, you know, flood restoration videos instead of electronic diagnosis videos. Schedule for the house. Well, it's coming along. It's taking forever. It's not too far off now, I don't think. So the painter finished yesterday, so that all the walls, ceilings, all painted now. There's no flooring down, no kitchen, no bathroom. So the flooring guy is supposed to be here last Friday. He didn't show up. I've been in contact with him this week saying, hey, what's going on? Because now we're waiting for the floors. So once the flooring's in, then we can start buying stuff to put back in the house, like, you know, a new washing machine, dryer, a bed, and we can actually start, get back into the house, live in the house again. And then we've got to wait for the kitchen to be put back together and the bathroom to be fitted out. The shower's got to be installed. They've got the shower trays in there, but there's no glass walls or anything in there. It's all not been done yet. The vanity is in the bathroom, but there's no vanity top and no tapware and that kind of thing. So, it's you know, if everyone got their act together, I could be in next week. But that's not likely to happen based on track record so far. I've not been happy with the builders. I've not been happy with the project manager. So it's there's aspects there which I think, well, you know, when this first happened, I said to my wife, we should just get the money from the insurance company and I'll fix it myself. And she said, oh, yeah, I haven't got time to do that. You know, she's saying, I just don't have time. And yes, it would have been intensive. It would have taken a lot of time to do that, but a lot of it was minor. A lot of it is like because my house is in 2 levels. The lower level was the bit that flooded the worst, obviously, and it's got solid floors through there. It's got tongue and groove flooring, so those floors weren't damaged. They got wet, but they weren't damaged. And all I really need to do is strip off the wall linings, strip out the insulation, replace those, put new flooring down. Right? Well, that's not a big deal. That's, you know, less than a week's work for me to do all that. But the upper part of the house has got chipboard floors, and chipboard does not like getting wet, and so all those floors had to be cut out, and that's something I wasn't particularly keen on attempting myself, mainly because I didn't really know what was involved. It's not something I've seen done or anything like that, but I wasn't really sure how they would fix it. So yeah, all they basically just went in there with chainsaws, cut around the floor on the outside, around the wall. So they cut off at the wall face, flush with the wall. So you put new flooring right up to the wall, because the floors are built on top of the floor, or the walls are built on top of the flooring. So it's not that the flooring goes up to the wall; it's actually the other way around. But the floor, the wall sits on top of it. So it's a bit tricky, but they leave that piece in there and replace the bit they can. So yeah, so now I know how it's done. I could do that myself too. But I wish now, in hindsight, like 4 months later, I'm still not in. It's like, well, I could have done this in less than a month myself. You know, I should have just got the money from the insurance company and said, right, thanks, and gone and done it. You know, you don't have to buy, you know, gear to do the work. That's fine. It still would have been a lower cost for the insurance company, and I would have been in there a lot faster. So yeah, it's been a bit frustrating. My wife is getting extremely frustrated with it. My tolerance and patience is a lot greater than my wife's, and yeah, it's annoying. It bothers me a little bit that we're not in yet, but you know, shit happens. You just deal with it. You know, you just deal with it and move on. You know, I know that we're going to get back. We'll be back in there eventually. We'll get there. And but my wife wanted to be in there 2 months ago, and so her patience is like none. She's got no patience. So, and once the house bit's done, then we've still got to do the garage, which is where I'm sitting right now. There's no bottom half of the wall. There's no. You can see a wall there behind me, maybe, I think. But that's it. Actually, I think you can see a piece of jute board. There's a sheet of jute board behind me, which wasn't damaged. That was a brand new piece which had to sit in somewhere. And that's just leaning up against the wall, covering up the hole in the wall where there's no bottom half of the wall. You know, so this bit's got to get done. This bit's easy. This is just insulation and gerb and plastering and painting. You know, this is really easy. I could do this in a couple of days if there's nothing in here. So anyway, what else can we talk about now? I think I've covered some stuff, haven't I? I've shown that already. I think I'll show you diagrams I've got for something I'm working on. I'll show you that, shall I? I don't think I've shown you on this yet. These are the diagrams for the voltage. Oh, sorry, they keep going on voltage thing. Leakage tester. Once Eagle opens. Yes, open that. Let's get the board design out. Board layout. I'll drag it into this window here. So this is the board I've designed. So I don't think I've shown this yet. We'll do that one. Yeah. So this is the leakage tester PCB, which JLC PCB have made, which will be here hopefully today. And basically what it is I've got a resistor ladder here down the side. How well is that coming up on screen? Is that coming up well enough? Let's have a look. Seems to be kind of okay, I suppose. It's not the clearest. So the left hand side's got a resistor ladder, which is high voltage. So one end has got fed in around 500 volts DC, and the other end is ground. And so between each resistor is obviously a step in voltage. Those values I don't know yet. I've got no idea what values I need. I'm not even sure if I'm going to use a network ladder like this. What I'm likely to use, as you would have seen my videos even earlier today, I showed you a bit, is just a high voltage pot, and just connect that instead of a resistor network, just having high voltage pot one into the other. With a set, obviously the common the wiper from that pot being the output from that resistor network effectively. So I've allowed for a resistor network in case a pot doesn't work. That way I can use a switch resistor network. And so I've got a header in here, just here. So if I do need to use a manual switch instead, then I can just plug in a IDC cable and onto a header, run the wires up to the switch and run them onto the switch. Just nice, simple, just plug in, done. Alright. So that's what that part there is about. So I've got two options there. We use a pot and don't install resistors, or I use a resistor ladder with a switch. Okay, so I'm going to try and go with the pot first, so it's fully variable in voltage. I don't know how that's going to go. Being as it's 500 volts DC, the pot may not like it. I will have to find out. If that doesn't work, then I'll use a resistor network. Over here I've got the these are capacitors here and diodes. So these are voltage. This is a voltage multiplier. So this is for me to effectively amplify the AC voltage coming in. So I've got 240 volts AC coming in, for example. It will double it potentially twice. I think that's what I've got on here. 2-stage. So I can't remember what I did now. So that can give me a much higher voltage. It gives me options about input voltage. I could run maybe 115 volt and then multiply that a couple of times and that kind of thing. It gives me options about what I end up doing. And then obviously in this bottom section here, which has got the shielding on it, I pulled the shielding back from this area here because you don't really want a ground plane near high voltage in case it arcs across. So I've intentionally taken it away from the high voltage areas of the board. I've only left the ground plane on the lower voltage section in order to help with shielding, keep noise out and that kind of thing, hopefully. And I'll try to keep it away from the high voltage stuff as well. No, fairly big gap there. I haven't got any isolation slots in the PCB. I thought about that afterwards, so maybe I should have put some slots in. We'll see what happens. If it arcs, then I'll have to get another PCB made with slots in. That's just simple as that. Or get my dribble out and start cutting. Because I've got 10 of these boards coming. So if the first board burns up, I've got 9 more. I'll just cut the slots in if I have to. It's manageable. So down here we've got... where are we? I have a tap for voltage input, and to try and remember what I'm doing. I've got some Zeners here as protection diodes, so 5 volt Zener there. I've got another one down here. Those are protecting the inputs to the Arduino, so it doesn't go above 5.1 volts. So if something happens, a resistor opens up, something like that, it doesn't try and shove the high voltage straight through to the Arduino and blow the crap out of it. That's there just as a safety. It could potentially go above 5 volts on the current shunt, for example. So I just want to make sure it gets throttled back a little bit and caps that off. So I'll try and which one's which now. I'm trying to do these feeds. So this resistor here, I've estimated a 0.1 ohm resistor here for the current shunt. So that goes to the negative side of the capacitor. And here I've got a voltage reference here, so that's coming through here somewhere. Just try and zoom a bit more. So that goes to an op amp, and I've also got a bypass pin. I've got a 2-pin header here. Zoom out this way a little bit so you can see a bit better. So I've got a 2-pin header there, which means if I don't want to use the op amp or don't fit it, I can just put a jumper pin across there, and I don't fit the op amp, but I'll just leave it unplugged. I'll be putting a socket in. And that means I don't have to use op amp. It just goes straight from this feed, from that negative side, through to the Arduino. So I've got a voltage divider here, 10k and 100k here, so that helps as well. And trying to remember what I did here. So I've got ammeter option here as well. So that's in series. So if I have an analog ammeter, it's plugged in or connected, soldered in here, or plugged in here. I've got 2 options there. If I don't have an analog ammeter, I just put a shunt across it. Same deal. So I've got these options about how I can configure it and what options I use to build it. So this is DUT. It's really hard to read. It says DUT, not out. Right, DUT. Right, so that's the capacitor basically go across those 2 terminals there. Right, so that side there is a test voltage coming in from either the resistor ladder or the pot, whatever I do. So it's got a common point here, so it'll go to wherever it goes to. And so that's then the supply goes across the capacitor or whatever it has to be testing. I'm assuming capacitor at this point. It could be used for transistors as well. Anything you want to test the breakdown voltage on. And so that then goes to this network here, which then does that, gives you a current reading. So I can measure the current through here because of the known resistance. And on the positive side, I've got a tap off here, which is 5 meg resistor and a 47k to give a voltage divider here as well. Which is also again, so I've got a 5.1 volt resistor Zener across there. That's then feeding the Arduino, so Arduino can see the current and the voltage. And again, I don't have to use an Arduino. I could just use an analog ammeter here and just leave it at that. I don't have to use an Arduino. But with Arduino, as you see, I bought a lot of the pins out, even though they're not used, they're not actually connected to anything. I bought them out anyway because I don't know what I'm going to do. I may well stick a header on here, for example, stick a pin header on there, and then run an LCD display. So I've got all these options open about how I do it. I probably do want to do an LCD display, but I haven't done any kind of thought into that process right now. Obviously, I've got a 5-volt regulator on the board. Because I'm using a Pro Mini Arduino, I don't actually need to have a 5-volt regulator on the board because it's got its own regulator on board. But I just like to do it anyway and just have one. So then I've got a 5-volt supply, which can be used for other things. If I need to tap off, say, an LCD display, which needs a 5-volt supply, I can tap it onto this. I could, I'll probably put like a header pin on the Arduino, so that when the Arduino is inserted, it's got a pin sticking on the top, so I can actually tap into the 5-volt off the Arduino onto its raw supply. Does the CCT work fine on prototype? I don't know. I haven't got the prototype yet. I'm waiting for the board to arrive. Hi Brian, how's it going? So this is the first design. This is just what I've imagined will work. There's no real testing. I haven't prototyped this up. I haven't done anything. I've just done a board. It could be a complete disaster. It could be it doesn't work at all. It could be I have to change values. I expect to change values. I may find I need to increase the resolution for the current sensing. I might find the current sensor is not enough voltage coming out, so I may need to increase that 0.1 ohm resistor to 1 ohm, for example, in order to get a bigger voltage increase across it, so I can measure it. Again, that's why I've got the op amp on there, so that if I need to amplify, I can just use the op amp and use that as a times 10 or times 100. I can't remember, I figured there now. Is that times 10? I think I did a times 10 on the op amp. So yeah, that'd be a times 10. Thereabouts. Well, shouldn't it be 90k, 10k? Not 100k, 10k? No, I don't know. Doesn't matter. Normally have a prototype going for the board. Yeah, that's right, you would. You would do that, exactly. But I'm fairly confident, and I'll make it work. You know, this is not for me to sell or anything like that. It's just me to play around with. It's just a project to mess around with. I mean, this has been made by JLC PCB. They wanted to do a sponsorship of my videos. You probably missed that. I don't think you were here at the time. So JLC PCB are sponsoring a video, and this board has cost me nothing. And I needed something to give them to make me, and I didn't have anything really I wanted to do apart from this project. So I threw this together in an evening. I think I spent about probably 3 or 4 hours making the circuit up and making the PCB. All right, design the PCB. 3 or 4 hours I think I spent on it. So there could well be errors in it. It wouldn't surprise me if there's errors. But then so I kept lots of options open as well. So if I do need to change things, I can. I've got various ways of working around problems built into the board already. That's why I've got it done. There's a bit of a mishmash of different things. That's why I'm settled on one particular style of handling the design, because I still don't know exactly what's going to work yet. I won't know until I actually get to build it. And rather than mess around with high voltage on wires and on crock clips and stuff on my bench and breadboards, which I'm a bit nervous about with having high voltage on a breadboard, and wire loops and stuff like that. I just wanted to build a board and do it all on there and see what happens. If it works or it doesn't. If it doesn't work, then I can figure out why it doesn't work and go on from there. As I said earlier on, PCBWay also want to sponsor videos. So if this design doesn't work, I'll go through line VAC. Yeah, this is 500 volts. It's going to be going to this thing. 500 volts DC is going to be ending up on this board. So yeah, it's high voltage. So it's I don't like messing with that on my bench, on breadboards and little thin wires and jumper wires. Like, don't go there. So I was saying, PCBWay also want to sponsor videos. So if this design doesn't work properly, or I need to make adjustments to it, that's fine. So I'll just rejig the board, send it to PCBWay for their sponsorship video. So as I said earlier on, the JLC PCB sponsorship I'm not comfortable with. They're asking a bit much. they're quite demanding about what they expect from the sponsorship, and I'm going to do this video, which as you say, they're committed to give me the ball. That's all fine. So I'm going to go through that commitment and finish that commitment with GLC PCB in this instance, and do that video. But after that, I'll probably not do that again. So it's a bit of a shame because they're going to give me money for each video I did and things like that. But there's a bit. It's going to detract too much from my own content. I didn't want to do that. But although GLC PCB are relevant for people which watch the channel, it's a bit much. I don't want to detract from my content. Okay, so that's that. Let's look at the circuit as well. Let's pull the circuit up, and why don't I see it on screen there, but I see it on screen there? Oh no, okay, yeah. So I thought it popped up in my OBS screen, my preview screen. I thought it popped up in there. It's not. It was overlaid on top of it. So I don't think, why is it there but not there? That didn't make sense for a second. So, right, let's pull this up. So this may give you a better idea of how it's working. So here's the resistor ladder. Let's zoom in slightly. So in theory, I can have about 550 volts DC maximum, based on these resistor networks I've set up for the voltage divider feeding the Arduino and that sort of stuff. So 550 volts DC is like the maximum I can put onto it, based on the voltage divider I've got set up. I don't expect to be putting that much into it anyway. So again, I've got this configured in a way that I've got sections. So I've got that ladder, which obviously goes down to ground at this end, and this is the feedback from the ladder. So the ladder could be either, as I said, either going to a switch, or I don't use the ladder and I have a tap off the ground, tap off here for a pot, which is more likely what I'm going to end up doing. So then the wiper from the pot will come down here, or the common from the switch, whichever one, comes down to this point here, which then goes through this divider. That's the divider there. This is a over here, so you can see it better. So this is just a current reducing resistor. That's just pure to limit current. So when you first switch on to load up a cap or whatever to test its voltage breakdown, there's going to be a current spike, and that resistor there is purely to reduce the current spike. From this side here, the that's positive. That is the high voltage feed that goes to the part under test. Right. So here's the resistor divider here, just to measure the voltage just going into the device. Okay, so it's just a nice little simple little block, just so it's easy to understand. And over here is the op amp section. Again, simple little block. So where we got here? Where are we? Right. Okay. So that's the negative terminal of the capacitor. Okay. Catch you later, Ian. Thanks for watching. Catch you later, mate. Yeah, I'm sure it's late there. It must be what? Must be 11 o'clock. Nearly by anyway. 11 or 12. I'm not quite sure what the time zone thing's doing. So then there's the ammeter option there, which I said on that. I can put a jumper in there instead. So that's the meter tap offs for the ammeter, for what knows. There's the resistor, the shunt resistor for the actual ammeter reading. So that's the actual ground point through that resistor there. And again, I've got a clamping diode here, so I can't get too high. And then I've got this bypass jumper for the op amp. So the op amp would go off, goes to the op amp, does that, multiplied by 10, whatever it is. And I've also got jumpers here for the op amp supply. So if I'm currently got this figured out for a ground 0 volt rail and a positive rail. Okay, that may not work. I may need to do a negative rail on the op amps in order to get the 0 volt level. I may need to go to a negative going rail. So because of that, I've left the option open. I put jumpers there, so if I need to change it, I can just change the supply going to that part. Again, it's because it's a prototype. I'm doing these things because I don't know what's going to work and what's not going to work yet. I'm allowed for things not going to plan. And so there's a jump bypass there, and that goes off. Now this then feeds up to the Arduino. Okay, so just go to the top of here first. So this is the high voltage multiplier. Okay, so I've got the AC coming in. Now you go to this voltage multiplier. I've got a few tap off points, so I can take voltages off different points. So depending on what configuration I use for the transformer, then I can tap off depending on as I need. So if I need to double it, for example, then I can just take off the first point, not worry about any other parts, and just not put those in. If I'm using a low voltage, like 115 volts, for example, then I may need to go through 2 or 3 of these stages, and so I might have to use all 3 of them. So I've allowed for different voltages on the transformer for the main supply. I probably won't use all of that. I'm likely to go with 240 volts. The transformer I've picked up, which I did do in the mailbag recently, it's just here. So this bad boy just here. So it's multi taps. Oh, try and get the right way. I think I'm looking like a mirror. So multi tap transformer. So I've got lots of options about the voltage I use as the input and the output. So I can use a different input voltage specifications. I can actually drop the output up and down. So you can do, where's its markings? It's got 115 volts secondary, so it's got dual 115 volts. So I can put 230 out. So I can add like an isolation transformer, 230 in, 230 out. I can do that. But it's got these other taps as well, which are 208 volts up to 460 volts. No, so up to 600 volts. Depending on the configuration of the winding. So I'll show you it there, hopefully. I don't know if the camera will catch it or not. You can try. Okay. And so based on the inputs, I can actually potentially boost it up or drop it down a little bit. So if I drop the secondary voltage down slightly by having a winding for higher voltage on the primary, then I could maybe double it or triple it and then get a more suitable voltage for use for the test unit. So I've got these options there. So this was not too expensive, this transformer. I think it was, well, I don't know, maybe it was expensive, but based on what I was looking, I think it's about $50 or $60 for this transformer. But I needed something like this, and I was looking around for a while trying to find something I could use, and this is the most suitable thing. So the next thing is the actual Arduino. Now, there's not much to see on here because I tend to just link onto the outputs and just name them so it links them all together on a diagram on the PCB layout, rather than having wires running everywhere. It's just a bit tidier. So this is a board which I actually did this footprint myself for my own projects. There wasn't a footprint for an Arduino Pro Mini as a device on a board. It just wasn't one. So I made this layout myself, and you know, it just makes it. I can just plug an Arduino Pro Mini into a board, any board I want to design, and drop Pro Mini onto it, and just use it. It's just nice and easy then. So yeah, it's just the basic stuff. It's not particularly exciting there, but as you see, I've got a whole bunch of inputs and outputs here, which are not actually going anywhere. I've got them brought out, as you saw on the PCB layout, but I've got nothing going to them. So what I'll probably do there is put headers on and drop an LCD display onto it. Use a serial or maybe a parallel display. I've got so many spare pins, I might use a parallel display and save the serial displays for later on for other projects. So yeah, hope you find that interesting. Yeah. So that 0 volt supply for op amp, I think, is probably not going to work. Because I had that in mind, that's why I allowed the option of being able to substitute a different voltage supply. Alright, so as you can see there, because I've got a jumper set up there, but because I thought the 0 volt rail isn't going to be good enough, I've got a 741 marked here, but I think I did actually buy some low dropout volt regulators. I did buy some low dropout ones, which have got the same pin out. Is that what arrived today? So I'm looking now. because these parts arrived today. All right, so I think these might be the ones I was looking at. Yeah, I've got a right sketch for the Arduino yet. That's not a problem. So I'm not even 100% sure I'm going to use an Arduino yet. I'm likely to. I've gone to the effort of designing it for it. But with a digital display through an LCD serial system is going to be responsive enough. I mean, an analog meter is nice to look at when you're trying to like watch how something's responding. A digital one, sure, you get a reading and you can see it quite quickly, and it'll update quite quickly too. More so on LED than LCD. But you know, it may you can see like a response curve from a meter, you know, an analog meter. You know, it might respond quickly and then slow down. You can see that more visually. Whereas on digital, you have to try and interpret the numbers, and it's not so clear. So I'm leaning towards using an analog meter, but I'm not 100% settled on that yet. So yeah, I will be writing a sketch for the Arduino. I do need to do that, but that won't be much. It's only doing voltage measurements. It's measuring voltages from the shunt resistor and from the supply going to the part of the test. So that's just voltage measurements. That's dead easy. It's not much at all. You know, they just give analog readings in, analog pins, and then convert that into decimal for the equivalent voltage. Which is why I'm also not too worried about the actual accuracy of the voltages, because I can tweak that in the code. I can allow for that. I can just change the division ratio and stuff like that. Yeah, that's right. The old the iTubes. Yeah, I was looking originally at the IT28 unit, and there's been a few on eBay and that sort of stuff, but the prices have been ridiculous. It's just silly money for what they are, right? And it doesn't tell you a lot. I mean, it's just got an iTube that opens and closes, and you know that's all it tells you. Obviously, you got the various scales and stuff like that, but I wanted more information than that, and so I was looking at those, and I did actually put some bids on some, and I never won one. There's the IT11 as well, which is not as good, but it does similar thing. So yeah, when I was getting to paying $200 or $300 for an IT28, I'm thinking, yes, it's a nice piece of gear. Will it need work? Maybe. Is it really what I need? Kind of, but not completely. You know. So because it wasn't really ticking all the boxes, and if it had been cheaper, if it had been $150, half the price, right? Then yeah, okay, I'd go for it because that's reasonable for what it does. But when they're getting silly money like that, it's because I think Mr. Carlson did a video on them, and then the price jumped. You know, the Carlson effect. And no doubt if I did one, it'd maybe push up slightly too, but probably not to the same degree. So I thought, well, I'll just build my own, and I'll do it in a more modern way. And I'm still using high voltage. I mean, Mr. Carlson did one. Someone pointed out in one of the other live streams. But Mr. Carlson did a video recently where he's done a low voltage version of a tester, which is interesting. It's available to his patrons apparently, so that's pretty cool. He's figured out a way of doing a low voltage one. But I want to see high voltage breakdown, so although he's got that method, I want high voltage. I need to see the breakdown voltages, not just capacitors, but it's also, say, for transistors and things like that. I want to measure that high voltage breakdown and see what the current is going to be like, how it's responding, how it's dragging the voltage down, that kind of thing. So that's why I want to measure the voltage and the current together in that way. So anyway, let's have a look at these parts here. Chatting a skip in 98. Oh, chatting a skip. Oh dear. That's sad. That is. Oh no. Such a waste. Damn. Yeah, it's sort of it's a bit modified now, really, isn't it? You know, think about it's an old piece of crap test gear. Chuck it out. but the old stuff is good. You know, it lasts and it's easy to work on. It's easy to fix. I mean, get a modern piece of gear. I mean, trying to fix that in 20 years' time or 30 years' time. Imagine trying to do that. You know, hell, trying to get it fixed in 10 years' time would be hard. What's this bloody part number again? Is it not easy to read? It's MC1458, was it? Let's look it up. The high voltage breakdown transistor, that came about when I was doing the Fluke 5200A. There's a transistor in the amplifier stage which is rated for hundreds of volts. And it has hundreds of volts across it. But what was happening, even though it's below its maximum rated voltage, it was breaking down and shorting out. It was around 100 odd volts or so. It's actually, I think it's about 120 volts, I think it was. It was breaking down and shorting out across the collector emitter junction. And it wasn't supposed to be doing that. And this is what sort of prompted me to actually try and make some progress towards getting this project done, because the transistor shouldn't be failing. You know, it's like, well, if I had a way of testing that transistor to check its breakdown, then I could have seen if it was okay or not on a piece of test equipment, rather than guessing what's going on. I had no way of actually simulating that, and no way to actually prove that transistor was failed. As long as you don't go above this maximum rating, then you should be fine. Yeah, I did see the video. I don't have a curve tracer. Yeah, I did see Mr. Carson's video about his device, and I thought that was very interesting. He did, you know, as you say, he did a comparison there, and it works alright in that situation. But hey, I want to do it my own way. You know, I want to do my own thing and see how it goes. He's obviously put a lot of effort into his, and lots of people will benefit from that, I'm sure. You know, from the Patreons that he has, they'll see that design. Eventually, that design will leak. You know, someone will release it or something, and it will be out there. And I'm sure he expects that to happen too. That's the way it's going to be. But yeah, I don't have a curve tracer. That'd be, you know, a good thing to test transistors with. I don't have a curve tracer, so. So these parts. That's right. That's what I'm trying to think about doing. Let's find these parts. Usually, if I buy parts, I also wow, he offered $1,000 and I threw it out. Wow. That's incredible. That's just wrong, eh? That's just smashed it, sledgehammer and dumped it, so it can't be used. That's just sad. That shouldn't happen, eh? I hate waste. I really hate waste like that. You know. Just trying to get this part number off here, make sure I got it right. Yeah, it is MC1458. I've got a similar data sheet, it might not be the right one. No. Okay. It mentions it in his data sheet, but it's not the right one. I have to look at it. But I'm pretty sure I bought a low voltage dropout op amp as well to put in there. This might be them, I'm not sure. Yeah, it's a shame I have to destroy stuff to get rid of it. It's just, yeah, just to avoid paying tax. I mean, God, you could just say, look, I'll give you the tax money, give it to me. It's like, yeah, that's a shame, mate. Just such a waste. I just hate that. Especially when I'm trying to rescue so much gear as well. I mean, I'm buying bits of gear which are broken, and I'm trying to restore stuff and get it working again. And to have that kind of thing happening is a bit, heartbreaking, really, isn't it? You know, there's some stuff we think, oh no, it's not. It's just way too old. It's not really practical to use it anymore because there are better alternatives, and it's not doesn't have much value. But other times you think, well, you know, something which still has a use is a shame to see wasted. Let's just try and find this part. I'm trying to get loading the windows open. Where are my windows? All disappeared. Because we've got them in the top window still. Right, oh, let's do a new window. There we go, it's down here. Let's just find this bloody data sheet and just see what the story is here. Go. I'm pretty sure it's a low voltage dropout. And I'm going to try and read the diagram and the notes. And my stomach's rumbling. Really? It's only 11 o'clock. Really, it's not lunchtime yet. Interesting. Where the hell is this information? I don't see it. Must have skimming too quickly. Probably not an exciting video watching me reading a data sheet, but yeah. So this particular one I've just got today is plus or minus 22 volts supply voltage, input voltage plus or minus 15. Differential input voltage plus or minus 30. So it's got a really broad input and operating range. Input offset voltage is 1 millivolt, 5 millivolts max at 25 degrees. No, it doesn't say what its absolute minimum output is. Not on this data sheet, anyway. Interesting. Anyway, I'll figure it out. I'll probably just play around with different op amps. I've got a few different ones. I've got these, I've got some UA 741s. And I've got some other ones. I've got a bunch of them which are all pin for pin identical, so I can try different op amps in the circuit as well and see which ones seem to work better. I can do some. I can just all do is inject a voltage at that point to simulate a load from a part under test, and then from there I can try and see how it goes. So I've got options there for how to do that. A working pick and place machine into the trash. Oh. Wow. Gear is dumped into landfill and cited by company tax rep. Oh dear. Oh, Daniel, you rescued the Tetronics, awesome. Trolley and plugins. Time-based control repair, okay. Oh yeah. It's always nice to see that bits of gear are being rescued and given new use of life, because I mean these things cost a lot of money when they first made, and that the quality, you can't beat the quality sometimes. It's just incredible. The detail and the effort that goes into making some of these things. Which is why I don't mind getting bits of old gear and trying to restore them, because it will pay for itself in the long run. I mean, this piece of gear, whatever it is I fix, I'm trying to, you know, repair the stuff which, or replace the bits which have aged badly, you know, such as capacitors. But most of it's all perfectly fine. You just carry on using it. You might get another 20 or 30 years out of a piece of gear once it's been recapped. You know, it's, it's so, if it's still useful, it's great. Writing down, that's common. Yeah, I mean depreciation on equipment. Yeah, it's just, you know, seeing the wastage is just horrendous. That really bothers me, eh? Okay, so what else can we talk about? What other projects? Oh, have I shown you this yet? New camera. Right, get it in shot. Right, this is my new camera. Now, this thing cost a bit of money. It's about $1,000. Is in plus I bought some accessories for it from Banggood or AliExpress, I think it was. I can't remember exactly which. There's like a hand grip you can add onto it, which holds 2 batteries, so you can double the lifetime of usage. You know, so you can use it for twice as long. There's also a DC power supply you can plug into it as well, which simulates a battery. I bought that too. So the idea is I'll set this camera up on my bench and use that for my bench videos. We'll see. I've been playing with it and trying to get a grip so it does so many things. It's a DSLR, but obviously its primary function is towards taking photographs. And also I want to do video with it. It's a bit different. Sure, I'll do photographs with it too. I'm sure I'll do still shots and things for like thumbnail images and things like that. But so that's what I'm going to be trying to use. I've got to get set up yet. I don't have a way of hanging it above my bench yet. It's heavier than my existing camera system, so it's too heavy for the mounts. I've got some brackets here which have arrived. Which are here, if I can untangle them from these wires. So I've got this bracket here, which is actually meant for mounting lights or whatever on it, so you can mount the camera on the bottom part here, screw it through there, and then you can mount other things up here or whatever. It's adjustable, you can change the size and things like that. So the idea of this is that I can modify this system, so instead of being a U-shape like this, I can have a bar coming out from my shelf, and I can bolt this onto the bar. So forget this piece, or that piece there, forget that. So it's got this L piece coming down, and then I can mount the camera on here. Okay, so the idea is I can sit it, when I drop it, get it round, so I mount the camera on there like that, so it faces downwards, and just have that whole assembly hanging off the bar. And so that's what I've got this kind of thing for. I've also got a longer bar coming. I think it's 30 centimeters long. So I may better mount that on the shelf, maybe some G-clamps or something, clamp it to the shelf, and see if that's long enough with one of these. Failing that, I've got some ideas about how to make a mount, but I can't really use this camera properly until I get the mount done. I did do some tripod work with it the other day. I did some video with the tripod. I don't think I published it yet, so that's okay. But I want to mount it above the desk. It gives you better options for lighting. Right. Easy charge pump is a maximum 232. Really. Interesting. Interesting. Well, because I'm using AC supplies, I'm going to have obviously I've got the main transformer for the main AC supply for the board, but I also want to have a sub supply for the Arduino electronic side of it. So it's going to be either 2 transformers, I'm not sure, or I may take off one of the other taps. So if you have a primary winding, then you can actually divide it down. So if I'm using, say, the 400 volt winding on the primary, if I tap off the 200 volt winding, I'll be getting around 120 volts, which I could then probably tap down to another transformer, give some isolation, or I could just put in parallel or whatever. So I'll probably have 2 transformers running, one running the Arduino side of things and one running the high voltage side. just to keep them isolated as well from that aspect, but share the common ground. Obviously, they'll be linked together, so you've got common ground. And then, because there's that potential there, I could have I send the transformer, so I can actually have a negative rail from the transformer, which I could then feed in. So I've got those options open to me. I'm not kind of locked in yet. $11,000 or £11,000 back in the 80s. Yeah. I've got a Tektronix 2432A scope somewhere. Yeah, it's somewhere. I can't think where. That originally was $10,000 US when they were first made. $10,000 US for that scope. I picked it up for $700. Now it's probably worth what? Maybe $300. I don't know. Is that what it's worth now? It's a 300 megahertz scope, but it's old and it's a bit glitchy, and I've had to repair it a few times because tantalum caps keep blowing. Maxim device allows a digital system of only 5-volt run with 12 plus a 12 volt plus or minus 12 volt swing. Cost of 2 capacitors and a driver chip. It does sound like a simple method, but as I am going to be having a secondary transformer anyway, or a second transformer, it's not going to be hard for me to use that to generate the plus and minus rails for the op amp anyway. It's basically already there, depending on which transformer I use. I've got standard 10 transformers here. I've got various ones sitting around from things I've purchased over years for various projects. I've got a whole bunch of like brand new ones which I just haven't used. So I've got some standard transformers there. So it's not an issue to create a positive minus supply. But running that IC is something to bear in mind. If it runs at 5 volts, that could also be a handy option. Do you know the part number for that device? Or is it just called the Maxim RS232 driver? I'll go and look that up. I'm sure that'll come up if I do a search. If I can find a Safari window, that'd be great. It's hiding the windows at the time because I've got it set up in the top. It's just like they've got a range of them. There's a Max 3233E. That's not it. That's something else. Max 251. Is that it? I'll pull it up here so you can see what I'm doing. Right, so that's what I've just found. So read. Doesn't say a lot about it. At least this part doesn't. That's not great. So I'll have to keep looking. If you know the part number, would be great. Max 232. Okay. I'm not quite looking at the right part anymore. PDFs. Go on, give us a PDF, it'd be nice. Let's put it on this page anyway. The Max 232 does ring a bell. I've heard that number before. So yeah, it says it's includes a voltage generator supply TIA, EIA, 232F voltage levels from a single 5-volt supply. I'm not quite sure what it specifies, what those levels actually mean. RS232 is not something I'm overly familiar with. And can accept plus or minus 30-volt inputs. Okay. I don't know. I'll have to look into that, but that could be a useful device. If it does what you think. Not sure. Anyway, I'm sure we'll figure it out. But yeah, I mean, there are standalone units you can get, stick in the boards, and then it can create negative rails, stuff like that. I know you can get them. I've not something I've looked into before, but when I've seen it, I thought, oh, that could be handy. So it's something I've sort of got in the back of my mind. Plus or minus 12 volt. Okay. 232D. Let's look at the data sheet here. And there's quite a bit of information in the data sheet. Good saying. Oh, some graphs. So it tells you the output voltages depending on loading. So, as long as you've got less than, say that point there, shall we? Less than 4K load, or more than 4K loading, it should be fine. Oh, yeah, that should be interesting. Right. So I'll have to look into this actually and just see what this involves. Whether or not this can be something which can be used in that way for me. And obviously it's meant for doing RS232 communications. Bunch of stuff there, spec there, okay. Alright. Interesting. So it's obviously generating those line levels, but whether it can be used as a power supply. You sure it can do that? You sure it can do this, actually run as a power supply rather than just as a signalling device? Because that's why I'm interpreting that as a thing which can generate those levels as a communication system for serial, rather than as a power supply. Because I know you can get those kind of modules anyway. I've seen them around. I haven't actually looked into them in a lot of detail yet. But, so in this situation, the transformers I've got, I do have certain transformers which can give me that negative rail if I need it. So when I build the thing, I will be using a center track transformer, if I can bloody say it, and going from there. So I've got the option. I'll build it with it, and see if I can get away with not using it. I'll make the center tap the 0 volt reference tied to the 0 volt from the other high voltage transformer, tie them together that way. Hopefully nothing horrible happens by doing that. The other options, I could run one transformer from the other transformer. That might be a safer way, but then I'm doubling the loading, but it may not matter anyway. It'll probably be fine. It's not going to be a huge load. Okay. So what else can we be talking about? Let's try and pop some other stuff. It's bloody Safari window, it's driving nuts. Keeps one in the wrong place. Let's just try and get it. Oh yes, that's the other thing. You may have noticed I've changed my name on my channel very slightly. I've now changed it to Defpom's Repair Channel to try and make it a bit clearer about what the channel's about. Well, that's the intent. So, I thought the Defpom channel, okay, once you've actually watched some content, you get an idea what it's about. But if you actually just come across it, it doesn't really say anything about the channel. So I thought I'd want to just rename it slightly and just try and make it a bit clearer. You know, I thought I'll just change it to Defpom's Repair Channel. It gives it some more meaning, and hopefully helps to attract people a bit more too. I don't know if anyone's even noticed. I haven't said anything yet, so maybe it's an obvious thing to change it to, and so you know, it makes sense, the logical thing to do. Right, I think I might wrap this live stream up, unless there's anything in particular we want to discuss. My stomach is growling away. I need to, you know, sort that out. And have a little snack. And have another coffee because I've been talking a lot. My throat's a bit dry now too. Let's close that off. Please use a fuse and transformer. Yeah. There's. Yeah, it will be a fuse supply. Always, anything mains rated, I always put fuses in mains rated stuff. If there's not already one present on the board, like some things have got built-in fuses, and that goes fine. But because it's going to be a transformer straight into the mains, I'll be putting a fuse in there. I've got some fuses I can use. And yes, it will be using a transformer from the main supply, stepping down most likely from that, and generating the voltages on the board from that. Fusion is free, you know. Dislike for using Tinkercad, really. This is new to me, alright, so Fusion 360, I've seen it mentioned. I'm intending to go and have a look at it. It seems it's a thing which is used a fair bit, so I think it's something worth looking at. I do intend to go and have a look at Fusion 360. This is my first attempt at doing a 3D CAD drawing. It's the first one I've ever done. Alright, so bear with me. I'm a learner. I should have L plates or something. I don't know. P plates if you're in Australia, or I don't know what you have in America. Do you have anything in America for learners? I don't know. Tinkercad is garbage. Well, I wouldn't go that far. Tinkercad so far has given me a good starting. Right? I don't think it's garbage. I mean, what I've done so far has worked. It's done what I wanted, and it's been okay. Right? It gave me the result I wanted. I was able to design something in it. So it's not exactly garbage. If it is garbage, I'd agree with you. If I had problems with glitching or losing the work, or doing weird things you wouldn't expect, I haven't had any of that. So maybe in comparison to proper 3D design software, maybe yes, because it's an online thing, you know, web-based. It's not proper 3D design software. So I can understand that in that context, but for my own usage, I would disagree. I think for what it does, for what it's designed to do, which is be a really simple, easy to use 3D bit of software, it works, and it exports it, and I've put it into Slicer, which I've got here sitting in the background here, which has got different key combinations, so so I put it in Slicer, and so it seems to have done the job right. I mean, it's it's what I expect to be the output. But yeah, I will be looking at Fusion 360. I froze 30 seconds. Yeah, my stream is not very good. My internet connection is not wonderful. It seems to be okay again right now. It's not dropping frames now, but yeah, my internet connection is not very good. So as saying, Tinkercad, it's obviously a very basic software, and for what it does, it seems to be right. But I say it's not proper software. It's not in comparison to proper AutoCAD or proper. I think of another name. I can't think of another name. There's another software I use at work, which has gone off the top of my head. So it doesn't. It pales in insignificance compared to those proper bits of software. So I don't think it's garbage. I think it's appropriate for the audience. It's just like a learning tool. It's an entry into the 3D design. So yeah, I will be looking at Fusion 360. I will be going to have a look at that. I'll definitely be downloading it and have a look and see if I can use that. I think the thing with 3D, from my learner's perspective, is that it's learning how to create the shapes. It's not just like you're building a block. You're getting a shape and taking pieces out of it to make the shape you want. And that's the concept which may be foreign to some people, I think. At least that's what I've been doing. I got a wedge piece, and I think I've got a rectangular block, and I took a slice off it using a wedge, and I've made this wedge shape. And yeah, it's worked. SelfCAD, I'm not even heard of that one. So this is brand new to me. I haven't used any CAD software at home like this before, so this is new. Okay, it should put that positive lines. I'll have to look into it. I would have to look into that device. Because even if I don't use it for this project, it could well be something I use for something else later on. And if a chip costs $5 or $10 or whatever it is, if it solves a problem, sometimes it's the most appropriate thing. Even if it's a bit more expensive, you might find that you might spend $10 on a chip, for example, but it might save you $15 from a transformer. So what layer height is that? I have that set at I think it's 0.3 right now in Slicer. If I can get the right key combination, that'd be great. There we go. Right mouse combination if I take it. I think that was a 0.3 slice. Yeah, because it was set. I think its default value of the slice is 0.3. The nozzle size on the printer I'm getting is 0.4 mil. There's 0.4 mil nozzle is what it comes with. So I'm not quite sure what the appropriate slice dimension would be. Maybe it should be smaller. I'm thinking it probably should be smaller, because it does look a bit coarse to me, but that's the default setting that was in the slicer program when I opened it up. But I'll be doing that other version which got recommended before. 0.25. Okay, I'll play with that. So 3D printing is new to me, so it's all a bit different. I've got a lot of learning to do there. It's something I've been wanting to do for quite a while, and I haven't actually played around with it yet. So trying to figure out the best way of doing it and what the best settings are is going to be interesting. Within 50% nozzle width. Okay, thanks for that. That's helpful. Oh yeah. I mean, I know there's lots of different softwares out there for doing various aspects, like the actual 3D design part and the slicing. I know there's lots of options, and that, in a way, it makes it very confusing, because it's like, well, which is the most suited to what I'm going to be doing? Oh right, you do. Oh right, okay. So you do 3D printing and stuff, but you're trying to learn electronics. Interesting. Bit of a crossover there, isn't there? You know. Okay. Okay, so 50% of nozzle width. I remember that. So the nozzle is 0.4 mil. I do remember that aspect of it, and it's got a heated bed and stuff like that. So it's 110 degree heated bed. I think I've still got it open. I'll show you what. I don't think you saw it before. Where are we? Safari and so yes, there it is there. I have to bring the window up. Right, so there's the printer there which I'm getting. It's already purchased. It's already on its way. So it's a 220 by 220, 250 high. 1.75 mil filament. I've ordered a whole bunch of ABS filament. Because what I want to do is build replacement parts, which is what which is what this thing is. This is a replacement lever for a PCB ejector system. So on the HP 4261A, which is a LCR meter, bit of an old piece of gear. I think it's from mid to late 80s, something like that. It's got little levers which you use to lift up, and it uses those to lever the boards out at the edge connectors, because it's got like a motherboard in the bottom, and all these daughter cards in it. And so there's levers, you just lift those up, and this is obviously a hinge point that's there, so you're leaving up by this end here, and this end here pushes against the side of the rack and levers the card out. And two of those levers broke because they're getting old, and this little bit plastics go brittle after a while, especially when exposed to heat or sunlight, either one. And so this is to replace those broken parts. So this is my foray into that stuff. So it's not the best printer for ABS. Well, it's got a heated bed, so I thought, well, that's a start. My background is actually plastics. I've been doing plastics for 25 years. So understanding how to work plastics, at least to a degree, is relevant to this. Obviously this is a bit different in the way it functions, but understanding heating and cooling and speeds and the balance and interrelationship between all those things is something I do understand. Yeah. Oh, it blocked you then. I'll have to unblock that. Okay. ABS can be a bit to print, cause a warping. Yeah, can warp. PETG. Okay. Doesn't PETG have to be dried first? Wouldn't it have to be dried? Because I know PET needs to be dried. ABS is supposed to be dried as well. You have to try and keep the moisture content down. Yeah, because you need to try and keep the temperatures up so it all welds back together properly, otherwise it will delaminate, wouldn't it? From the differences. So, I mean, there's things I was thinking I could probably maybe use as a heated box, like a bit like that, where it is like maybe a hot air gun or something blowing towards it to keep that environment warmer. That kind of thing, just to try and help it to melt together, to fuse together on each layer. So. And that will also help with warping as well, because if you keep it a larger temperature differential between what it's printing and what's already there, that should reduce the warp. So if obviously the bed is there to help that, so it keeps it warmer. So that it's that temperature differential where the new stuff's coming on hot and the old stuff's cold. So when the new stuff cools and shrinks, it will curve it up. No, okay. Because I've only ordered ABS filament at this stage because I believe PLA is weaker. I haven't used PLA before myself either, so I'm not familiar with. I'm familiar with ABS. I've used ABS myself in other applications, right? In my plastics industry, in my plastics career. So ABS I'm familiar with. I'm comfortable with ABS. So I'm not too worried about that. Yes, I understand the warpage could be an issue. This part is quite small. I don't know if you can see it from the grid pattern here, but this part is only 28mm long. And obviously I built it upside down, so it makes it sensible to print. Right? If I did it the other way up, it'd be harder to print. So I've done it that way up, so it prints correctly. And it's only, I think it's 10mm high. I think it was something like that. PLA beats ABS in strength, really? Okay. I read the opposite of that. I suppose I can get some PLA and actually do some real world tests as well. I've only ordered ABS at the moment, but I can get some PLA and actually do some comparisons, because I want to use the strongest material I can. So if I can get whichever one's strongest, I don't care what it is really, as long as it's strong. So I'm sending you a handful of these PCB levers, various sizes as well. This is designed for that HP 4261A. So this is, well, I've measured up what they already had there, and I've modified it. I've made it stronger. Okay, interesting. Yeah, any moisture content in plastics is not good. They weaken it, especially during processing. Like in this case, when you're extruding, any moisture in the plastic will turn to steam, and it will create voids inside the plastic, and it even stops the plastic merging together and welding together. It will actually stop that from gelling properly and things like that. So you can get all kinds of issues. So moisture in plastics, in some plastics, can be a real issue as far as getting a good product in it, because it will make it brittle and weak. You can get that. So I have access to material dryers, so I can actually put my filament in a material dryer and dry it down to the stuff which is used in plastics industry. Right. So yes, nylon is particularly sensitive. Equally, nylon, if you over dry nylon, it gets brittle. So nylon actually likes to have a little bit of moisture in it. But again, you don't have too much. If you have too much, then you get issues. But it can actually, if it's over dried, it can be too brittle. You can see effects it can have. Polyamide 66 in particular. That's what comes to mind anyway. I actually have a diploma in plastics, so I actually have a little bit of understanding about it. But only the stuff I mostly use, so I don't know a lot about all the plastics. It's just, PLA is a foreign one to me. Yeah, so moisture over time as well, because plastics absorb moisture as well. Usually once it's been made, it will be better, but off to work. Hey, thanks Pete, catch you later. So yeah, once it's been made, then the moisture is less of an issue. Make a video about techie for plastics. It's complicated. Yeah, I've been doing plastics for 25 years in industry, but I'm not a materials designer. But I have done training, and I've got a level 4 diploma and stuff like that. A level 5 diploma in plastics processing, which is using the gear and understanding the processes. And I've got level 4 in plastics materials. So I've done a bit of training in it. But I don't have like a degree or anything. I've never been to university to do it anyway. So there's guys out there which know a lot more about it than I do. I just happen to have a bit of understanding because it's my job. So you know, but I've my experiences with polymethyl methacrylate or PMMA, otherwise known as plexiglass or acrylic, ABS, ASA, PVC, polypropylene, polyethylene. I think that covers it. Those are the materials I'm familiar with. Well, plastics basically, once you understand the heating purpose is purely to allow the molecular chains to slide past each other. That's what the heating's doing, right? It's to freeing up chains so they can slide past each other on molecular level. And now the length of those chains determines the strength of the plastic, the brittleness of the plastic, like impact resistance and all that as well, and how easily it will flow once it's heated, and at what temperature it will flow once it's heated, and like this interrelationships between like things like interchange as well. So entanglement. So at molecular level, I can get ASA filament. ASA, I liked ASA. I've used ASA. I liked it. I found ASA to be a good material. It's nice and stiff. Gives a nice surface finish. I liked ASA. That's good. It was a little bit stiffer, but it worked quite well. Yeah. So the temperatures you use on any plastics process is purely you only use as much heat as you need to in order to get it to flow and to flow with proper melt. So depending on the molecular structure, and if you've got like large items within the molecular structure, like benzene rings, things like that, then they need a higher temperature to melt, and they take more to get them to flow. So that's what influences the melt temperatures. And so, although it specifies, I saw some mentions of ABS being like 210 to 250 degrees melt temperature. Well, I process ABS at 190 to 200 degrees, and that's flame retardant ABS. It's got some additives in it to make it flame retardant so it doesn't burn. But yeah, I mean, a lot of times that'll be like a maximum. You know, that's like really, you don't need to use that much heat. You only need enough to make it work. If you're having issues with adhesion, then yeah, you want to put more heat in, so you gotta, so it stays hot for longer, that kind of thing. Yeah, if you do it as hot as you can, you're going to get better merging between each layer, because as it's cooling, it'll cool. Obviously, it'll be at a higher temperature before the next layer comes on, so it helps them to fuse together. Obviously, if you go colder, then you won't get as good fusion between the layers and that sort of stuff too. So, bear in mind, I've never used a 3D printer. This is just my theory about how these will work based on my plastics knowledge of how things work that way. So using a hotter temperature means you're going to get that fusing better, but you may get more. You get more stringing. You get more stringing from the nozzle and that sort of stuff. And you can actually degrade the plastic as well. If you go too high a temperature, it will degrade the plastic and make it weaker. It will go brittle or burn. You can lose properties in the plastic. What happens when you burn it, the molecular chain shorten and it changes the properties of the plastic, which is why they go brittle as well. Yeah, I mean, some materials are going to string out more than others. Yeah, so again, it's anything like that, anything involving plastics, it's a balance. You have to find a balance between time, pressure, flow, and temperature. All that, it's always a balance, and working out what that actually is in any circumstance it can be time consuming sometimes, regardless of what you're doing. You know, 3D printing versus industrial manufacture, which is what my experience is. It's always just a balance. So working out what works for you is what's important. You know, regardless of what the theoretical parameters should be, you just find what works. No, okay. So yeah, you know, it's been many times I've read a data sheet for a material and I've gone, okay, so this is what it seems to think in the data sheet for its operating range for processing temperatures, and you go to actually use it and you go, actually I don't need to be anywhere near that. You know, a good example would be polyethylene. Right? The data sheet for that recommended a temperature of around, I think it's about 250 to 260 degrees Celsius, and I found it worked best at about 215 to 220 degrees. in the application that I was using it in. So just because the theory says it should be this, you just do what works for you, because it's not always right. Those theories are based on lab tests and flow rates and things like that. So yeah. Is it okay to eat PLA? I wouldn't know. I'm not familiar with PLA. Was it polylactic acid? Isn't it? Polylactic acid. That's what it stands for, isn't it? I don't know. I've got no idea. I probably wouldn't recommend eating any plastics, really. I think PLA will actually break down the environment quicker than other materials. I think it's so commonly used because it's for prototypes like that, because it is more biodegradable. That's my understanding, but I don't know much about PLA. It's not something I've got any experience with. I'll just from little bits I've read here and there. But it's not necessarily just the base material as well. There could be additives in there, which you probably don't want to consume. Yeah, when I get the printer going, well, actually, when it arrives, obviously you see a mailbag video of it arriving, and I'll probably do a video of me putting it together and building it, and then I'll likely do a video of my attempts to try and get it working, and see how it goes. It could be an interesting prospect of me trying to figure out how the hell to do 3D printing. You know, again, it's a big learning experience for me. It's not something I've done before, so it will be interesting. It's definitely going to be a newbie perspective on it. Most definitely, it's going to be something I'll do. Anything I work on, I don't always video everything, but I try and video a lot of things I work on, and that'll be something I'm going to make an effort to try and do, just to make sure that's covered. So I'll do videos of my initial setup and things like that, and testing, and first print, that kind of thing. Carbon fibre blended pit too. Carbon fibre, right? That's quite a nice rigid material at the end of it, isn't it? Got fibre in it. CF blended PLA. What's CF? I mean, a lot of plastics are like polypropylene, for example. That's food grade, right? A lot of things you get, like fast food trays and things like that, you get from takeaways. Those little clear plastic trays, they're often polypropylene, because there's a food grade version of polypropylene, because it's naturally not considered to be harmful. Door handle from back door. Oh, okay, carbon fibre. Okay, yeah, got you now. Interesting. I mean, I know there's lots of different filament types out there. I mean, this printer I'm getting is a very basic printer. It's not like a, as you saw, it's only a very simple thing. But because I'm just starting to get into it, I don't want to spend a lot of money on a printer if I'm not going to fully utilise its abilities. Or if I'm not, going to make use of those kinds of things. So, well, I'll just get a simple printer for now. Get my head around it, get used to it, and figure out how it works. Maybe on the hard end of the scale, because maybe they're not necessarily so easy to use. Being a cheap printer may be limited, but they give me a good intro into it and getting into playing around with that kind of thing. And the things I want to make are usually small and simple things. As far as strength goes, like the thing I want to do, one of the things I want to do is these handles for this Valhalla AC calibrator. I'll show you again, because in case you wouldn't hear me. So let's try and get a stream picture up so I can see what I'm doing. Alright, so let's make this bigger. Here we go. So this is what I want to make as one of these. Right now, this is being glued back together. I've got two of these handles. They've got brass inserts in them, and these are both smash, and I'll need to make new ones of these. And obviously this is picking up a piece of test gear which weighs about 15 to 20 kilos, so I need them to be strong. And like with the with this thing, alright, I've redesigned it to make it stronger. When it comes to doing these, I'll do the same thing. I'm going to redesign this design to make it stronger than it is originally. Alright, so things like here, it's sheared off here, okay, because it's attached to these 2 points. So it's got shear force here and here. This is like a bending force. Hold on a second, let's get this phone. Let's see what this is. And now, so I'm wanting some radio work done for, well, a CB aerial fixed on a truck. I don't do CB aerials. I don't do internal installations. So where was I? Yeah. So this has got, it's got a shearing moment here. I have some engineering knowledge too. So that's a shearing force here, and that's a bending moment here, right, in this section. So this bit's trying to bend, and this bit's trying to shear. So those 2 forces not strong, right? And here's probably not too bad. That's a tension, just there's a tensile moment there, right? So this bit's under tension. This is a shearing moment. This is a bending moment. All those forces together, not great. So what I'm going to do is change its handle so it comes down here. So it's directly in line with the anchor point. That way, it's a tension, not a shearing or not a bending moment, right? And I'll beefing these right up as well, make them much thicker, give a lot more metal, a lot more meat there, and the same for this rail that runs along, make that a lot beefier as well, and let's make it all a lot bigger. There's no anchor points in here at all. These are purely just like slots inside the casing. It looks nice. So that's the 2 anchor points. That's all that holds it. So everything needs to be beefed up to this area here, you know. So that's what I'll be making as well at some point once I get all that figured out. Nylon X, carbon fibre blended nylon. Okay. Well, anything that's got carbon fibre in it is going to be strong. You made your own printer. Okay. Yeah, I know that can be done. You can buy the bits and you can put them together. You know, get like just a frame. You can get the controller and get the heads and that sort of stuff. You can build your own thing up. It's I've seen that as a possibility as well. Yeah, I mean, going for the cheaper printer, I mean, obviously there's the cost aspect, right? So there's initial outlay. There's also justifying it to my wife, because she might complain if I spend $1,000 on a printer. She probably will complain if I spent $1,000 on a printer. So then from having a basic printer, I can find out what the limitations are and what I cannot do. And then from that, I'll know what I need to look for in future if I were to upgrade the printer. 650 kilos, awesome. So yeah, anything that's got carbon fibre or any kind of fibres, glass fibre, that sort of thing. Glass fibre is more for like abrasion resistance, toughness. Carbon fibre is obviously for that sort of thing too, but it's cheaper. I think carbon fibre is cheaper. I'm not sure, I can't remember. But any kind of fibre or filler in plastics is going to change properties. If you have bead is great for abrasion resistance, but not so good for strength. Anything tensile on bead, forget it. It can actually add a negative effect. But any fibres, any fibre fillers, they will increase the tensile properties of the material. Anyway, yeah, so this is something I'll be doing later on as well. So I'm quite looking forward to getting that printer. Let's put this back up here before I lose it. But so I had to glue those back together first, so I can actually get the dimensions off them and measure them up, and so I can model them. I haven't done the modelling on those yet. I'll be doing that soon. Like, maybe I'll get that Fusion 360 and do it in there. I mean, yeah, I mean it's a printer. I mean, the principle of it is that they heat the plastic up, melt it, and stick it onto a bed, right? In that aspect, they all work the same way. The level of control you get will be what's different. You know, how finely you can control the movements, how finely you control the feed, how accurate the temperature readings actually are. I mean, you get a temperature reading, is it right? You know, is the head, the heating element, and the thermocouple section there, is that accurate enough for that nozzle temperature? I mean, because there's going to be, you're always going to get thermal losses when you go into a nozzle or anything like that. So, how bad are thermal losses between the heating element and thermocouple pickup and the actual nozzle? There's kind of differentials as well, things to consider. Yeah, so I mean, because of my plastics background, I'm more confident about using a more basic thing. I'm confident I can work around issues because that's what I do as a job. So, working around issues, that's, you know, making things work. That's what I do. So, I'm fairly confident with that. But again, it's going to be limitations. You're going to expect that. I mean, there may be the possibility there to even do upgrades on this printer later on. I mean, once you've got the frame, you can always change out parts, can't you? You can always put a new controller in or change the motors, as you say. That is an option. I could always just, as long as the frame is nice and sturdy. I mean, it's an aluminium frame, which is what I've gone for that, rather than a plastic frame. In the belief that will be more robust and more sturdy and less movement within the frame. Because if you've got movement in the frame and it's moving around, it's going to jiggle it. And so it might need cross bracing, maybe, I don't know. But yeah, as you're saying, rigid frame, yeah, that's right. And that's why I've gone with this aluminium one, because I thought, well, aluminium frame's probably going to be more rigid than a plastic one, as long as it's well designed. And aluminium could be worse than a plastic one if it's not designed in a way which makes it rigid. It could still have some slop in it. It could move around a little bit like that. You just don't know. So yeah, it's going to be an interesting experience, you know, having a dig at 3D printing and see how that goes. Yeah, well, I'm going to cut the stream off. It's been very interesting. Have a good chat. Oh yeah, yeah, yeah. So yeah, upgrading is something I've got in my mind as well. You know, once as long as the frame's good, then it's worth doing that. Yeah, no worries. I think we're almost going there, really. So I'm going to head off. I'm going to cut the stream off. So thanks everyone for watching. And so there'll be some videos coming up with the 3D printer and this leakage tester PCB when that arrives, which should be here soon, actually. So thanks for watching. Catch you later. And enjoy the rest of your day, evening, night. Have a good sleep, whatever you're doing. Catch you later.